Off air. Now you're live.
Hello, hello, Kent. This is Kent Hovind in Lenox, Alabama, and I have with me by Skype Stefan. Is it Frello, I guess, from Denmark, and wants to have a debate on the topic of creation versus evolution. So we're doing this live on our YouTube channel, Kent Hovind Official. Tell your friends to join us. Stefan, we've tried to get this debate for quite a while, and I appreciate your patience on this, trying to get all the technical stuff worked out. I asked if you would go first. You said the topic of the debate would be about homology, similar structures. Does that prove evolution? I'd like you to tell a little bit about yourself, what you believe, and if you could start off and give your evidence of why you think this homology is evidence for evolution. So go ahead, Stefan.
Okay. I'm a molecular biologist and a mathematics. I have a PhD in botany from the University of Copenhagen. And I have worked as a scientist for about 10 years, but now I'm a teacher in mathematics at the level just under the university. I have I just opened this slide thing, PowerPoint I have made. I hope that's on the screen now.
Yes, sir, I see it. Okay.
We agreed on the topic of patterns of homology or non-homologous anatomical and genetical structures, whether that can be thought of as evidence of evolution, and that's what I'm going to argue that it is. First, I hope we can agree on the definition of terms that evolution means the descent of modification through natural selection, working on random mutations, and this can result in accumulation of genetic and anatomical complexity. At least that's the claim that it can, and the result of this is that all living organisms are related through common ancestry. And in opposition to that, creation is the sudden miraculous appearance of different kinds of living organisms. And they can experience some change, but only within certain limits. And therefore, different kinds are unrelated. I hope that we can more or less agree on those definitions. Otherwise, we will have to discuss that too. Okay. How could we identify whether what we see is design or evolution? At least in human design, what is easy to observe is that the same kind of units are used in very different devices, such as the same kind of batteries in this example. But under evolution, you would never see exactly the same complex structures in very different organisms. You will always be able to identify a gene or a protein exactly to what organism it comes from. So that's a very profound difference between human design and evolutionary design, if we should call it that. Just to make sure that everybody understands what we are talking about, very, very basic genetics. DNA is our chromosomes and the basic information of what makes every single organism like it is. This is through a process called transcription. Is a molecule called messenger RNA produced, and this is used for translating into protein. And the protein is mostly where the function is, and also a lot of structure is defined by proteins. So in this way, a sequence of DNA is transferred into a sequence of amino acids, which defines a protein. So this is how it works. One thing that is very easily detected in high organisms is the mitochondria. It has its own genome, and part of my arguments will be based on the mitochondrial genome and the homology and lack of homology in the mitochondrial genome. As it says here, there are a number of proteins in the mitochondrial genome, but only very few. Only actually in animals about 13 protein coding genes, and a number of other genes. Other organism has various number of genes in their mitochondria, but all higher organisms, all multicellular organisms, and a large number of single cellular organisms has a mitochondrium. If you sequence the DNA of the mitochondrium from various animals and compare them, this pattern could emerge if you start with the wolf and compare it with various more or less related species. If you compare it with its well, the same, not only the same genes, but some will say the same species, the domesticated dog. It's a little, depends on who you ask whether the domesticated dog is a specific species or the same species as the wolf. But it has a very high homology with the wolf, 99% homology in the mitochondrial genome. If you compare it with another species in the same family, for instance here the fox, you get much lower homology, 85% in this case. If you compare it with species within the same order of mammal, the carnivores, in this case the domesticated cat, you get still lower homology, and so on through placentals and on to marsupials and monotremes. And if you compare it to another class of vertebrates, here I have used a chicken, a bird, you get still lower homology. This is exactly what you would expect from evolution. Exactly. That within very closely related organisms, you should expect very high homology in the genes, and you should expect lower and lower homology when you compare species that has a common ancestry that is further and further back in time. And therefore, all mammals should share more homology between them than to any animal that is not a mammal. And all carnivores should have a higher homology between them than any mammal that is not a carnivore, and so on and so forth. And this is what you see all over the place. It doesn't matter if you start with the wolf, or you start with the domestic cat, or you start with the blue whale, or you start with humans. You see exactly the same pattern. And I look forward to see your response to this. How can this be explained within a creationist pattern or a creationist worldview? Actually, this phenomenon of the homology has been researched very thoroughly by Nathaniel Jensen, who is with the Answers in Genus in Research. Journal has published this picture and a number of other pictures like it. It is showing the homology of the mitochondrial genome between a lot of different animals. You have to imagine all the animals going up the yellow axis and along the up the vertical axis and along the horizontal axis, and along the diagonal. Well, my English is not good enough for this. The slope going from the upper left to the lower right corner, you have comparing this one animal with itself, and the rectangular areas are closely related species. It has been highlighted where the mammals are. I hope that you can see it. It is in the lower right corner of the great red triangle, and the red squares are indicating high homology, and the blue areas are indicating low homology. So the red square in the lower lower right corner is showing that all mammals has higher homology with each other than with any other animal, just as you would expect. And this is made by creationists. So it is not. It is you can trust it if you trust creationist scientists. He made this kind of investigation in all the different mitochondrial proteins and found exactly the same pattern in all of them. A very, very strong indication of relationship. Of course, he interpreted in another way, but that's a different story. Also, you can make another kind of test of this homology. If you compare the domesticated dog again with the wolf, the mitochondrial genome again, you find that they are identical except for about 170 positions. But within the fox or the dog family, you have a lot of differences. The greatest difference I found was between a species called the grey fox and one called the doe, and they had about 2,400 different positions, which means that there are about 15 times more variation within the dog family than there are between the domesticated dog and the wolf. And I don't think there's any disagreement that the domesticated wolf has, or the domesticated dog has been together with people for at least 2,000 years, and most people will agree that it is much longer than that. So, if the accumulation of differences in the dog has been more or less the same as in the rest of the family, then it is impossible to explain how the maximum differences can be 15 times higher than between the wolf and the dog, because that would take at least 30,000 years. It would be impossible to explain within a very short time frame of about 4,000 to 5,000 years. So I'm looking forward to your comment on that too. Another kind of homology is, of course, anatomical homology. Here are a number of examples of anatomical homology and non-homology, more or less. All the three to the right, the whale and the human arm and the dog wing, all are more or less the same structure. You see we have one arm bone and then two bones and then a number of small bones and then the fingers, and that's the same in all three. The shark skeleton is completely different, and you could say that, well, the three to the right is looks the same, or looks more or less the same, because they have the same creator, but the shark should have the same creator too. So why do the whale flipper look more like a human arm than like a shark fin from a creationist point of view? From an evolution point of view, it's exactly what you would expect, because the whale and the human has a common ancestor that is much closer to us than the common ancestor we have with the shark. So I look forward to your comments on that too. Other homologous structures, the famous example of the vertebrate eye, very complicated thing. The eye in the middle is the eye of a squid, an octopus, and they look very much the same. But if you look at the details, you can see that the dark green area, which is the nerve cells, in the vertebrate eye, they are on top of the retina, the light detecting cells, which is in the opposite direction in the eye of the squids. there the nerve cells are below the retina. So this this difference between the structure of the eye of vertebrate and the squid is a mollusk, and all eyes in mollusks, they look quite different, but they all have this structure that the nerve cells are beneath the light detecting cells. Of course, the eye of an insect looks completely different. But why? Why is there this difference? That's and why does it follow exactly the larger taxonomical groups? Why are all vertebrate eyes identical in this respect, and why are all mollusk eyes identical but different from the vertebrates? Here to the left, I have found a picture of various different mollusk eyes of different complexity. Yeah, we can go back to that if you want to, but the main part of that is that all of them has this structure with the retina on top of the nerve cells, regardless of what the structure is otherwise. In arthropods, which are insects and spiders and their relatives, there are also various homologous structures in the eyes, but they are completely different from the vertebrates and the squids. The spider eye is not a compound eye like in the insects, but still they have the same basic structure as a compound eye in an insect. Also, exactly what you would expect from evolution. Yeah, I go through that. This is just to illustrate a question that I wanted you to reflect upon. The hummingbirds. This is a picture of the smallest hummingbird and one of the largest dragonflies, and they are actually to scale. They are approximately the same size, and so their eyes are the same size. They are both flying. They both need to see in order to navigate when they are flying. But of course, the hummingbird has a vertebrate eye, and the dragonfly has a compound eye. But and under evolution, it couldn't be any different. It had to be like that. If we found a hummingbird with a compound eye, that evolution would fall apart. It would be impossible to explain. But as I see it, why should that be so? Why haven't a creator decided to give the hummingbird a compound eye if it works so well for the dragonfly? Or vice versa, why hasn't the dragonfly got a camera eye like the hummingbird if it works so well for a flying animal? I don't think it's obvious that it should be like that if creation is true. But of course, it's obvious that this is what we would expect if evolution is true. The same is true for various other homologous and non-homologous structures, like the legs of these different animals. They are performing the same function for walking, but they are completely different structures. While in the arthropods, you have different animals, so the crab and the spider and an insect, and even a horseshoe crab, these strange-looking creatures, and the basic structure of their legs is the same. And these animals are actually living in very, very different environments. Some of them are flying, some of them are living in the bottom of the water, and some of them are crawling around in the vegetation, and all kinds of different lives or environments. And still, the structure of their legs is more or less the same. Again, exactly what you would expect from evolution. They have the same, a common ancestor with this general structure of legs, which has been preserved through evolution. there is a term called vestigial structures, and there is some confusion about what it actually means. It does not mean that we have a structure without any function. It just means small and imperfectly developed. This is from the Dictionary of Biological Terms. Small and imperfectly developed, not necessarily without function. It can have a function and still be vestigial. I have inserted two pictures of hind legs from whales. Basilosaurus is a fossil, a very, very common fossil. It is known from, I think, dozens or even hundreds of specimens. So it is a very, very well-known, well-described species. And it clearly has all the bones for a hind leg of a vertebrate, exactly what you would expect. The other one is from a modern whale, where you can see it very, very reduced, and you can hardly even imagine what bone is homologous to which in the Basilosaurus. But still, it is positioned in the right place in the organism, in the body of the whale, and it has actually some of the same functions, because some of the muscles, as you have pointed out yourself in some of your videos, some of the muscles in the whale, which is connected to these bones, has a function in reproduction. And in other vertebrates, there is also muscles connected to the same bones, which has more or less the same function. Also, when you look at various structures over time in fossils, sometimes you can follow the reduction of these structures. The Amblicitus, the structure or the leg, fossil leg to the left, and the Basilosaurus are both extinct species of whale, and you can see that it is more or less the same structure, but in the Basilosaurus it's much more reduced. To the right, I have a picture that shows that some of the details of the leg bones of fossil whales actually are very, very much like the same details in the so-called even-toed ungulates. In this case, it's a pronghorn. I don't know why they have chosen that, but that's just one species of the many, more than 100 even-toed ungulates living today. And they all have this very special structure in their leg bones, which is only present in the ungulates and in extinct fossil whales, which is an indication, the first indication that we got that whales actually are closely related to ungulates, which is quite surprising, but that's the way it is. And this is actually supported again by the mitochondrial genome. High homology, of course, within the whales, especially within the baleen whales, but also with toothed whales. And the next group with high homology to the whales is the hippopotamus, it's called the Cetatiodactyla. Very, very strange name, but that's a group that is both the whales and the even-toed ungulates. And the hippopotamus is an even-toed ungulate, just like cattle and pigs and sheep, antelopes. And you can see that the homology in the mitochondrial genome is actually higher when you compare those species with the whales than if you compare any other mammal species. Also telling the story that once in the past the even-toed ungulates and the modern whales had common ancestor. That was more or less it for opening remarks. So I will go back to this one, I think. I hope so. Or do I have to stop the sharing?
I don't know.
No.
Stop sharing.
Stop sharing. Yeah. Okay. So I just open it later if we need it. Yeah.
Okay. Now, how do I call mine? Now, you would think because of the similarities in all these computers, they would be evolving.
They are. They're getting faster and faster.
with some intelligent design, I think. Okay, share. There you go. Okay.
In that case, we agree.
All right. One of the evidences always given for evolution is what you spent the last, 25 minutes on, is homology, that because things are similar, therefore they must be related. And the more similar they are, the more closely related they are. Just on its face, if you step back 5 feet and look at that argument, anyone with half a brain and one eye would see how silly that is, because similarity could just as easily be argued for a common designer. I think we can analyze all the music ever written by Bach or Chopin or Mozart and find similarities in all of their scores that they wrote, or their musicals or whatever. And that does not prove that they are evolving. It proves that they are coming from the mind of the same individual. The same would be true of all of the books that an author writes, like Louis L'Amour, the famous Western writer here in America. His books, and I read probably 120 of them, I don't know what he wrote, but they have thousands and thousands of similarities, proof it's coming from the same mind. So the big first thing I would get across is that, yes, I agree, there are similarities in all these animals, and similarities in the eye structure, and similarities in thousands of ways, but that has nothing to do with proving a common ancestor, and everything to do with indicating the same person designed them, and that would be God. So homologous structures are not evidence on their face for evolution. They're evidence for common designer. Now, you are correct. All of the textbooks use this argument that because these bones are similar in the animals, we have 2 bones in our wrist, the radius and the ulna. Hang on, let me write the time down here. The bat has 2 bones in his wrist, if you call it a wrist, the radius and the ulna. I would agree. There are similar structures in all the vertebrate animals for sure, and even I think maybe that's where it stops at the vertebrate animals. But all of the textbooks use this as evidence for evolution. And if you just again step back 5 feet and look at it, that is just as silly. It is evidence of a common designer. I think you notice nearly all of the cars on the road in Europe, and all the cars on the road in Asia, and the cars on the road in America, as a general rule, have 4 tires touching the ground. Well, that's proof they all evolved from butterflies. No, it's a design that works. It's a necessary design to have 4 tires touching the ground for stability and for ride comfort, etc. Why don't you have 20 tires touching the ground on your car? Well, because it's unnecessary. It wears out the rubber too fast, and too much friction with the road, etc. So I think a God who would design things would design each of the animals so that their forelimb can be rotated and twisted. To invent a machine that can do what the human arm can do would cost millions of dollars, maybe even could not be done. When you consider the human arm not only is able to do all these various motions, it is also able to heal itself. I don't know if anybody's made a machine can do that yet. If it gets an injury, it heals itself. All the machines I've ever had, I had to go fix them someplace, take it to a mechanic and get it fixed. So I agree there are similar structures. I don't think anybody's arguing that. The question is, what does it prove? In your mind, Stefan, and in the mind of evolutionists, this is evidence for evolution. Like this biology textbook says, other evidence for evolution. And then this is what you have. You've accumulated a whole bunch of bits of information that you think are evidence for evolution. Each one can be independently destroyed in a common sense argument. But somehow, because there's an accumulation of all these bits of false information, it looks like there's an overwhelming pattern of evolution. This essential biology book from 2004 is homologous structures, anatomical signs of descent with modification. I would point out, first of all, why are they saying it has to modify through descent? We never see this. It's never observed. Cows produce cows, cats produce cats, humans produce humans, and they have the same bone structure without exception. I'd be willing to bet if we went back and dug up the grave of your great-great-great-great-great-great-grandfather, he would have 2 bones in his wrist, just like you do. There has been no modification. You still have 2 bones in your wrist, and probably your great-great-great-great-grandchildren will have 2 bones in their wrist. Evolution is never observed. It is only imagined. It only takes place in the mind of those who want to believe this. We see 2 bones in the wrist of the humans, of every human being alive, if assuming they're born, other than some catastrophe or genetic defect. So, yes, I agree. We're looking at the same evidence, Stefan. We're both seeing the similar structures in these animals. I agree. Hold on. However, we're coming to very different conclusions. I would point out that thousands of parts on a Honda Civic will fit on a Honda Prelude. Thousands of parts, interchangeable parts. Well, that's design efficiency. Probably the lug nuts would interchange. Okay, that's proof they're coming from the same designer, not proof of evolution. This textbook says the commonality, or comparative anatomy here, provides further evidence of evolution. The commonality suggests that these and other vertebrate animals are all related. They probably evolved from a common ancestor. That's what the books are constantly teaching the kids, and obviously that's what you were taught going through school growing up, and you believed it. I think it's just common sense to say, look at this. First of all, this structure is amazingly complex. Each one of these bones, whether it be the tibia, the fibula, the patella, the radius, the ulna, the humerus, whatever, each bone is phenomenal. It's able to grow and function while it is changing size. It functions when you're a child, and it functions when you're an adult, and every stage in between. So you have all this bone structure that is able to work while it is changing. This is evidence of an amazingly intelligent designer. I look at just one single bone in your arm and say, wow, thank you, God, you're so smart. The bone is both strong, slightly flexible, and lightweight. And the harder you work the muscles, the more the bone will grow in response to that. You have a bone that's able to sense a need for more density based on the more work you do. That's why a bodybuilder will not only get bigger muscles, but bigger bones. So we look at these bones in these animals, and I see amazing design. What a great God we serve. And you see a common ancestor, which ultimately goes back to dirt, which goes back to nothing. I don't understand how you can see that. This textbook says, commonality suggests that these and other vertebrate animals are all related. They probably evolved from a common ancestor. That is complete propaganda. That is silly. That is a lie. It could prove a common designer. All the bones, by the way, that from these different animals, whether they're for swimming or flying or digging or running or grasping, if you really get into the DNA analysis of this and the gene code, you'll find they develop from different genes in different organisms. I've never heard an evolutionist explain why the similar bones in a bat, compared to a human, for instance, why is this bone developing based on the genetic code of very different genes? Okay, this Irish textbook shows comparative anatomy of the different animals. It says, look at that, we've all got fingers and wrist bones and arms. I agree. And it's used all over the world. I have textbooks from a lot of different countries. Here's one from Latvia showing the same thing. Here's one from just a few weeks ago. Someone sent me a 2015 textbook showing, again, the similar structures. And I don't argue with that. I agree. But what does it show? It proves a similar designer. Lug nuts from a Pontiac will fit on a Chevy. That's because they both evolved from a skateboard 4.792 million years ago. And you can go to the junkyard and dig up fossilized Chevys and find out the lug nuts probably still fit on a modern Chevy. That's not evolution. That's common design. So we both are observing similar forelimb structure. We're both observing the homology. It's a good observation. But to conclude they had a common ancestor is a bad conclusion. And to say this all helps prove we came from a rock for no reason with no help is a really bad conclusion. I could point out that I quickly wrote down a sentence. The sentence in English, Please bring me a bat. I can change one letter. Please bring me a cat. I have completely changed the meaning. Please bring me a car, changing one more letter. We could play around and develop thousands of sequences like this where one tiny letter change in a very complex sentence can make a completely different meaning to it. Well, that's how all languages work. That's how your language would work there in Denmark. You can change one letter and have a vastly different meaning to the word. So changing one little gene on a chromosome might make some vast difference in the outcome of the creature, the animal, the anatomy. That, again, is evidence of intelligence. I don't understand how anybody can see anything other than intelligent design. Why would they even dream? It shows we're related. And you mentioned, oh, no, you didn't mention the development argument, but you mentioned evidence. Oh, I think we need to go back and define. You showed pictures of a wolf and a dog and the similar gene structure. Again, I would point out that's correct. They probably have similar genes because they have similar functions to serve in life. I think you would find Microsoft PowerPoint, which I use all the time, has probably millions of lines of code. Microsoft Word, to do documents and letters and writing, has also millions of lines of code. And if we laid them side by side, I think somebody with the time and energy and a government grant to do it could find many tens of thousands of identical lines of code. You could probably go through Microsoft Word and Microsoft PowerPoint and determine that they have a certain percentage of similarity. Let's say it's 95%, okay, to pick a number. Okay, I agree. What would that demonstrate, though? If you find similarities in Microsoft PowerPoint and Microsoft Word, and I assure you you would find millions of identical lines of code, would that then prove that they're all related to Morse code and that they evolved by chance, or that it's a common design? When I click spell check in PowerPoint, it probably takes me to the exact same place that spell check in Microsoft Word takes me, or any other Microsoft program. So the fact that there are similarities is not evidence for evolution. And an honest science researcher should tell their students and anyone listening to them, hey, boys and girls, hey, men and women, we have similar structures between the wolf and the dog. I agree. There are 170 differences that we've discovered so far in the place settings of the genes. Okay, let's assume that's true. I would say I agree. Then an honest researcher would say there are two possible ways to look at this: common ancestor or common designer. But the evolutionist is not being honest with their students. They're only telling them you must look at this as evidence of a common ancestor, when it is not. It's evidence of a common designer. Let's see, I wanted to get to one more thing. You mentioned about the wolf, the fox, the D-hole having a different 2,400 different positions. Again, they have similar functions to serve in life. They have two eyes on their head so they can have binocular vision. That is a common, hang on. It's very common for creatures to have, did I get it right, Steve? To go to the eye. I don't have my mouse here. I don't have, oh, you got it, okay. The whale, okay, the whale evolution right there, okay. Does it, brings me up to the right PowerPoint? No, I guess not, okay. We have moved it here, I'll get to it. The fact that there are similar needs, I think many cars, whether they're made the Lada in Russia or the Volvo or the Honda, they probably all have a spare tire and a jack, because they need that. Things go wrong, things break. And so they have similarities because of common problems they face in driving down the road. You're likely to get these same problems. And so if you watch my video number 4, Lies in the Textbooks, I go through all of this on different, explaining all the evolution evidences that are much better explained as a common, here we go. I want that one, 698, let's see, Alt-DV. 698, enter. Okay, now I need to go off screen. Or is that okay like that? Hit escape. Okay, and then enter. There. Okay. You mentioned about the whales and the pelvic bones. Let me just explain to the listeners what this is about. This textbook shares what I would call the propaganda Just imagine whales walking around. It's true. Here's the Los Angeles Museum of Natural History, has a skeleton of a whale. And it shows these bones you're referring to down here in the abdomen area. Here they are, another view inside that circle. And they call it the whale's pelvis. And say this is evidence that the whale used to walk on land. Wow, just imagine the whale walking on land with those little tiny bones. Actually, these bones are used in all whales that I'm aware of have something similar to this, and they're used in reproduction. The whale has to mate underwater in the dark with no arms, and he can't talk and say, "Scoot over, honey." They have a penis 15 feet long. They have to maneuver in the dark. So both male and female whales have ways of maneuvering their sex organs because they don't have any hands. Because this is a way to get baby whales. So if you want to believe that this is evidence that it used to have a leg, you're welcome to believe that, but that's not really science. That's a religious belief. All we see is whales, every time they're born and grow up, have the exact same bones. That's all they have. All the ancestor whales had this, and the modern whales have it. I'd be real cautious, though. I'd advise you, Stefan, to be cautious about using any fossils as evidence for anything. Because I've said many times, when you find fossils in the ground, like a fossil whale, really all you know is it died. You could not prove that that particular one had any children. You certainly couldn't prove it had different children. And why would anybody think bones in the dirt were capable of doing something that no whale today can do, which is produce something other than its kind? That's why evolution only takes place in the imagination. It doesn't happen in real life. We never see it. And science deals with things we can observe, study, test, and demonstrate. Evolution is not science. It's completely religious. Here's National Geographic. It says, millions of years ago, dolphins had legs, showing the same hind legs. They've got the picture right here. This is propaganda. This is a lie. Those bones in the dolphin are used exactly like the whale. They're used for reproduction. They're not leftover hind legs. Someone can believe that if they want. It says, this textbook, this guy's very stupid about his whale anatomy. He said the whale's pelvis is located far from the vertebra and has no apparent function. He needs to go back. Whoever wrote that book needs to quit writing books on biology and go back to school. We've got one of the whale bones in our museum. That's one right there. It has a generous blood supply. It is a very active bone. I'm sure as active as the whale can get it. He'd love to use it more, probably. So it is part of their reproductive system. Has nothing whatsoever to do with walking on land. That is propaganda. But it's used all over the world. Here's one from just a few months ago. Still being used as evidence for evolution. Said it's evidence of evolution from four-legged land-dwelling mammals. A couple of thoughts I'd like to make, and then you can go on to your points here, Stefan. One, we don't see any animals produce anything other than their kind. We never see this. Two, these whale bones are used right now today, and they're always the same. Three, fossils do not prove anything. You can't prove it had any children. And, oh, I'm sorry, I had to cough here. Secondly, this example from the whale is a classic example. Even if it were true, it's an example of losing something, not gaining something. You're saying the animals lost their legs, and that is evidence of improvement? Show me an example of a creature that is gaining something. To go from legs to no legs is a loss of information. Now, it didn't happen. They didn't go from legs to no legs, but even if it were true, that again is the exact opposite of evolution. The bones in the whale are used. They have, like I said, a blood supply, nerve supply. They're used, and they used all the time. They are not evidence for evolution. Finding Ambulocetus or one of these creatures that are mostly imagination is evidence that something died. That's all it is. In a real honest court of law, it would never be used as evidence of anything. I'm sorry, of anything changing into a different kind of animal. So if you find fossils in the dirt, really all you can demonstrate is it died. It is not evidence of any evolution at all, unless you want to believe that. And I wish you evolutionists would be honest and say, students, this is what we believe. Capital B, believe. This is our religion. You need to start a church, the Church of the Evolutionist, and quit using tax dollars to spread this propaganda as if it is part of science. Like this one from Berkeley University, this couple months ago. Hippos likely evolved from a group of these creatures 15 million years ago. That's silly. Hippos are still producing hippos. Whales are still producing whales. You don't have any evidence for evolution. None. You can believe that if you want, but I'm sorry, it's not science. Okay. You left several. I didn't get time to cover several things. I'll get it during rebuttal here. Go ahead. Stefan, your turn.
Okay. I just open my... I don't want to do that. No, you have to close your screen share first. So, like that, yes, okay. Group. We just happen to have the same the same picture. Well, here is this Ampelocetus you mentioned. I found a picture of a much more complete well, the argument in evolution is always the argument of patterns. Single observations is not evidence of evolution, or very rarely, but patterns are evidence. And the pattern here is quite clear. I just show you. Well, first we have the hind legs here of Ampelocetus and other fossils, and of the Basilosaurus we have the hind leg here, which is much more reduced, but still with more bones than in the modern whales. And at the same time, in the same fossils, in the same found in the same layers, we have the little red dots. You have to look at the right part of the slide. We have 4 different whale ancestors, and what we can see is the little red dot is the nostrils, and you can see that from Pakicetus to Rhodocetus to Dorodon to modern whale, the nostril is moving backwards, one little step at a time, and at the same time, in the same fossils found in the same layers are the reduction of the hind legs, and at the same time in the skulls you can see that the structures in the inner ear is adjusting to life in water. So it's not just a few singularly observations, it's patterns of observations. A lot of different kinds of changes from one fossil to the next points in the same direction, that this is actually ancestors of whales slowly adjusting to the life in water by moving the nostrils from over the time, moving backwards and up on the top of the head, and at the same time the hind legs reducing in size. Now, what you didn't talk about, you talked a lot about these vertebrate legs, but what you didn't talk about was my actual point that I just see if I can find it again. Where do we have it here? That the wave flipper, though the function and the overall look of it is much more like that of a shark fin than like that of a human arm, but still the skeleton is vice versa, very much like a human arm and nothing like the shark fin. Now, according to your point of view, the shark and the whale has the same creator. They have a common creator. Why on earth would this common creator, this creator that created both the wave flipper and a more or less identical structure in the shark, why would it give them completely different skeleton structures? And why would he choose a skeleton structure that so clearly indicates that this creature is related to land mammals? In all respects, the whale is a mammal. I hope we agree on that. And also parts of the skeleton that has close resemblance to the rest of the mammals' skeletons, though the actual function of the limb is much more like that of a shark fin. That was my question. The pattern is the question, not the individual observations, but the pattern of observation is the question. Then you use parts of cars and parts of computer language and things like that as examples of identical units fitting different programs or different cars. Exactly. That is exactly my point, Mr. Hovind. You have identical units. In nature, you never see identical units in very different organisms. The dog wing is not identical to the human arm. And the mitochondrial genome of the whale is not identical to other whales to come here. I think the wolf is better. Get up here. Yeah, there it is. The mitochondrial genes of the wolf is not identical to the fox. They serve exactly the same functions. It is not identical to the mitochondrial genome of the domesticated cat, but they serve exactly the same function. Why are they different? Why are they not just exactly the same? All mammals, most animals actually has exactly the same 13 protein coding genes in their mitochondrial genome. Exactly the same. They serve exactly the same function. But you can trace the homology exactly the way that evolution would predict. It's a pattern that is important here. They are not identical, they are more or less homologous, and the more or less follows exactly what we would expect when you look at the anatomy. But the important thing here is that the mitochondrial genes has nothing to do with anatomy. They serve completely different functions and exactly the same function all over the place. So why this pattern? That's what I'm asking you. Why is there this pattern? In human design, you don't find a pattern of something that is more or less the same. You find patterns of something that is completely identical or quite different. My computer mouse and the front light of my bicycle uses exactly the same kind of battery. Not more or less the same kind of battery, but exactly the same kind of battery. You can take the battery out of the front light and put it into the computer mouse, and it works perfectly. You see never something like that in living organisms. You can make it work if you take a gene from one to another. Yes, it works, but they are not naturally the same. They are always slightly different, always following the pattern that more or less corresponds to the pattern of anatomical differences. So it's a very different kind of pattern in living organisms and in human design. Then you say kind produce kind, dogs always produce dogs. Yes, but no one, you cannot find any biologist in the world that would say that you should expect, under evolution, you should expect differences to accumulate in a pace where you can actually see it. But well, this is millions of years question that we strongly disagree on. We can talk about it in more detail if you want. But time is a very great issue here, as you know. If you have a million generations, then very, very slight differences from generation to generation can accumulate into organisms that is completely different. The language analogy is actually Well, that's actually interesting because the language analogy, you change one word and then you get something else, and then you change another word and you get something else. Well, if that can happen in language, then why would you say that it could never happen in genes? Why couldn't genes, by changing small parts now and then and here and there, and keep changing and changing and changing, if language can lead to something completely different, then why shouldn't genetics be able to lead to something completely different by slowly changing? But well, I don't think. I actually think that the language analogy is pretty good analogy of evolution. Not very good, but pretty good. There is no accurate analogy of anything here in the world. Analogy has always its backwards. What was it more? Yeah, well, I don't know if I forgot something, but I would like to make a little provocative thing here, if you will allow me. I just have to find it. Just a second. Again, on the pattern of homology. I guess you know it, but here it comes anyway. This is again on the mitochondrial genome. Genus Pan has two species, chimps and bonobos. They are almost identical in the mitochondrial genome. If you compare chimp mitochondrial genome with all other mammal mitochondrial genomes, well, as far as I know, I have actually done quite a lot of work on this, and I have compared chimp with, I think, 100 different mammals, and the one that comes out with the highest homology, guess what? It's humans. 91% homologous. Orangutan is somewhat lower. Gorilla is in between. And then comes another monkey, and then comes other placentals, and then other mammals, and then, of course, other vertebrates, non-mammal vertebrates here, the chicken. But the important part here is that either I'm not sure what your view on the created kinds are. But other creationists claim that the chimp and the gorilla and the orangutan is the same kind, the same created kind, and actually has a common ancestor not so long ago. But that would be completely inexplicable by the human interference with this. But I don't know your view on biblical kinds. So it might be that you think that this is no problem because orangutan is a different kind from the chimp. I don't know, but still, why this pattern? Why we have exactly the same genes? We have exactly the same function of the genes. They are not identical, but they are homologous, and the homology shows exactly the pattern that will be expected if you look at the anatomy of the animals. What is the idea of this? Why do we find this? I simply don't understand how creationists can explain this. The only person I have come across that has tried to explain this kind of pattern is the person I mentioned, Nathaniel Jensen from Answers in Genesis, and his explanation is, well, silly. It's simply stupid, because what he claims is that all these mitochondrial genes has multiple functions, and I don't think that he has thought about this explanation, because it actually would mean that every single one of the 13 genes should have hundreds of different functions some of the functions in mammals, and some of the functions in insects, and other functions in unicellular organisms, or in plants, or in fungi, or whatever. It's remarkable that a scientist can come up with such a stupid idea. But I would urge you to give some comments on the pattern here. It's not just homology, it's a pattern of homology. It's not random homology, it's a pattern. Very, very strong pattern. And the pattern is exactly the one that you would expect if you look at the anatomy. The placentals has a somewhat different reproductive system from the marsupials here, the kangaroo, and all the placentals are more homologous in the mitochondrial genome than any of them are with the kangaroo. All mammals more homologous than any of them are to any of the birds. All birds more homologous than any bird is to any fish or whatever. Why this pattern? That would be my main question to you. And then again, give some comments on this shark, whale, human arm system too. Yeah, I think I'll leave it there.
Okay, am I on, Steve? How do I? Hey, Steve. I think I have to screen share or something here.
I have closed this.
My mouse is not working. Yeah, hold on 1 second here. We're waiting for it to evolve. Give us about 14.6 million years, and we should be fine. There. Oh, there it is. Okay. Yeah, and this computer technology and Skype and all the satellites is primitive compared to one DNA. Okay, share. You want that one?
More or less true.
Hang on, my techno guy is trying to figure it out here. There we go. Well, that one. Okay. Now for me to screen, just to talk. Okay. Yes. Well, thank you so much for doing this, Stefan. I think you've clearly demonstrated that it's a religion. You said no evolutionist would say that we see things happening, changing, because it takes millions of years. That is exactly my point. It's outside of science. It's not observable science. It's something you believe in, but nobody sees this happen. Nobody. The octopus eye. Let's see. I'll find it here. I think I can multitask here. Okay, let me find. You said there's a pattern. The pattern is just as explainable with a common designer. Example, the Honda car, or let's take the Chevy car, has 5 lug nuts that are a certain size. But when you go to the Chevy truck, now all of a sudden you have 8 lug nuts that are bigger. So they're not identical. So because they're not identical, but they serve a common function of holding the tire on, and there's more of them and they're stronger, that in your mind is evidence of evolution. When actually, that's evidence again of the common designer. So it looks like you want it both ways. If things are identical, that's evidence for evolution. If they're not quite identical, that's still evidence for evolution. Okay, well, the Chevy truck and the Chevy car do not have identical. No, I want the octopus eye. Well, yeah, that'll do. Okay, right there. Yep. Let's see. That'll go here. The human eye. Okay, 23. Got it. Okay, right there. Charles Darwin was very confused by the eye, like as he should have been. Screen share. Okay. Because any eye, you brought out the vertebrate eye, the eye of the insect being a compound eye. Anyone who studies biology or anatomy will know any eye of any kind is beyond belief in its complexity. The retina of the human eye is about a square inch, but it contains 137 million light-sensitive cells, all connected to the brain. And you mentioned the fact that we have the one evolutionist I debated, and you brought up a similar concept here, is that the human eye is poorly designed. Hang on, get the time down here. Because the blood vessels are in front of the retina in the human. And the octopus or the squid or animals that live underwater, the argument is they have a better eye because the blood vessels are behind the retina. Well, this is ludicrous. The blood vessel's position in front of the retina or behind the retina is dependent on the designer designing it that way for whatever its environment is. Octopus live underwater, and the water filters out most of the UV light coming in, so they don't need the blood vessels in front. We live in the air, and air is not a good filter for UV light, and so the blood vessels is the body's last defense against burning the light-sensitive cells. So it's again further evidence for design. If you want to swap eyes with a squid or an octopus, you go ahead, but you'll be blind in a few weeks from the UV light. So the design of the squid's eye and the design of the human eye are mind-boggling. If you could get a computer that would do or get a camera that would do what the eye does, you'd be wealthy. 137 million light-sensitive photoreceptors in 1 square inch. I don't know what pixelization is down to now. Steve might know. They've got some pretty high-resolution cameras, but nothing even close to the human eye. Nowhere close. And this is very intelligent people working with very expensive equipment, trying to produce something to mimic what God did when he created it. To say that any eye of any animal or insect or vertebrate or non-vertebrate evolved is ludicrous. It's not science, that's for sure. Okay, you asked me several specific questions. The whale flipper and the shark fin serve a similar function. I agree. Huh? 10,000 per square inch is the most we have now for pixelization for cameras. Okay. And the human eye has 137 million. I don't think they're going to get close. No, we're close. Okay. So, and this is with intelligent people trying to make it happen. You think it happened by chance that we got 137 million. I admire your faith, Stefan. I do not admire your science or your conclusions. Okay. Sharks and whales have flippers and serve a similar function, but different design because they both live in the water. I think a diesel engine and a gas engine serve a similar function. They both propel a motion of some kind, but they're very different in their design. A rotary engine in the Mazda RX-3, 4, and 6, and 7, or whatever, 8, 9, I don't know how high they are now, but the rotary engine is phenomenal. I've had a couple of them, and they are amazing to drive, but they are completely different than a piston engine or a jet engine, and yet they serve a similar function. Is that evidence of evolution or evidence of some intelligent designers? They have rear engine drive cars and front engine drive cars and midship engine drive cars. They're all trying to accomplish the same goal. So the shark has to swim in the water and the whale has to swim in the water. So God designed them very differently. I would agree that by our modern classification system, a whale is considered a mammal. That does not mean that's how God classifies them. I think most 5-year-olds would say if it swims in the water, it's in the fish family. They have to be taught that it's not a fish, that it's actually a whale, and I'm perfectly fine with that. It has hair, gives milk, bears live young. I'm familiar with the mammal classification system that Carolus Linnaeus came up with. But the Bible says the whale, Jonah was swallowed by a whale. In another case, it says he was swallowed by a fish. So apparently in the biblical classification, a whale is in the fish category, which is perfectly reasonable. It does not mean it's wrong. It means our classification system is different. You probably have different words in your language than I have in my language for certain things. Probably just about everything. So the pattern of evidence is that the whale and the shark both have a common designer. That's the evidence. That's how I see the evidence. You showed the fossils of the red dot moving, the nostrils moving. I'm sure you're aware, Stefan, if you studied this, that it's a whole lot more. See, the whale with the nostrils on top of his head, you have to disconnect the trachea and hook it up differently. How's it going to survive? Well, all of a sudden, see, the animals like whales can breathe through their nose, which is not go through their throat, because it goes straight to their lungs, because they've got their mouth open, swallowing water at the same time to separate the krill or whatever their diet's going to be. So you not only have to just move the bone in the skull, you have to completely disconnect the soft tissue and reconnect it some other way, so it's redirected. This is absolutely impossible, even to dream up an idea how it might happen. The airway is different. I've never heard an evolutionist answer that one. It's not just a matter of moving a red dot on your picture. And plus, again, you go back to the evidence from fossils with the red dot in a different picture. You can't prove any of those are related to each other. So you found an animal with nostrils on the front. You found another one with nostrils a couple inches higher. Okay, that is not evidence in any honest court of law that there's any connection between the two at all. You could get buried on top of a hamster when you die, and that does not prove you're related to the hamster. Order of burial in the dirt does not prove anything. Moving dots on your picture does not prove anything. Let's see. I think I've covered most of your questions. Oh, apes and chimps. I don't know if they're the same kind or not. The Bible says the animals will bring forth after their kind. That word baraminology in the Hebrew is being studied, and the current estimate, the last I heard, was there are 8,000 kinds of animals that would have to be on Noah's Ark. Kinds, not species. There are 1,100 recognized species of bats in the world. They might have had a common ancestor, a bat. There are 8 different varieties of bears in the world: the brown bear, black bear, panda bear, grizzly bear, etc., polar bear. They might have had a common ancestor, I don't know. Noah might have had 2 pairs of bears on the ark that were different, and they now have 8 different varieties. He might have had 2 different kinds of bats on the ark. I don't know. I don't know where the kind is exactly, but I'm not asking all the taxpayers to pay for my religion to be taught in the school system. You are not only asking, but demanding. The evolutionists are demanding that their religion be taught at taxpayer expense, or they come take away your property if you don't pay your real estate tax, which is what pays school taxes over here. So I think that whether apes and chimps are identical, I would doubt it. I think Noah probably had 2 chimps and 2 apes and 2 humans, well, 8 humans. And I don't know if where the other ape-like creatures fit into the category. But to start with, say, 6 or 8 or 10 reproducing pairs in this family of what we consider the apes as a general category, and to develop all the varieties we have today, that is certainly feasible. But you guys want us to take this evidence and believe these apes and humans came from a rock 4.6 billion years ago. That is extremely silly. It is not science. I do admire your faith. I do not admire your science. Stefan, that's your religion, and I wish you guys would just admit it. Nobody's ever seen an ape or a chimp or a human produce anything other than their kind. You believe it happened, you dream it happened, and you dig up a bone and say, aha, this is evidence. None of those bones count in an honest court of law, and anybody that's honest would recognize that. No fossils count. So I think I've covered your questions. If I missed one, bring it up again. Your turn, Stefan.
Okay. You have to close the share screen. Hello?
Yeah, let's just go a few more minutes. I've got a couple other things. I got to do something here?
Yeah, you have to close the share.
Stop sharing. Okay. Which mouse? This mouse. Okay. Stop sharing. Yeah, you go ahead and give some closing, and I'll give a closing, and then let's...
Okay. The eyes of vertebrates and squids. Well, I remind you, Mr. Hovind, that fish live in the water. They are vertebrates. They have vertebrate eyes with the wiring on top of the retina, just like you would expect vertebrates to have under evolution. So your explanation, and on top of that, some snails are living on land, but they have the retina and nerve cells in the same direction as the octopus. So your explanation of protecting against UV light is, yeah, I cannot put that in a polite way. It is silly, Mr. Hovind. It doesn't fit the facts. Then you said that I'm not doing science. Well, we have I have to talk a little bit about what science is then. Science is about testing theories. That's what science is all about. You have a theory, you make predictions. If the predictions are met, you are happy. If the predictions are not met, you are also happy, but you have to make up another theory, or at least adjust the theory. The theory of evolution says that you would expect to find fossils in the soil, and those fossils should look as transitional forms leading to the forms that live today. And that is what the whale fossils does. They look exactly what you would expect. They have the nostrils on the right places. They have the reduction of the hind legs. They have the adjustment of the inner ear to hearing underwater, and so on and so forth. They are exactly what you would expect if evolution is true. And that is the way science works. You don't have to make observations of everything. How should I put it? Newton knew that, and Galilei knew that Earth was orbiting the Sun. But nobody has ever seen Earth orbiting the Sun. Nobody has seen it. And still, we have known that for more than 300 years. You don't have to make direct observations in order to do science. That was that. And still, I simply don't think that you are relating to this pattern thing. I have shown you these very, very detailed list of homology that exactly matches what you would expect. And remember, this is the way science works. You have a theory, evolution. It says, well, okay, the genetics, if all these animals has a common descent, and they have common ancestors, and some has a close common ancestor not so long ago, and some has an ancestor longer ago, and some has a common ancestor very, very long ago. What would you expect? You would expect anatomy to reflect the distance to the common ancestor. Very close, very homologous anatomy if you have a common ancestor not so long ago, and very different anatomy if you have a common ancestor a long time ago. And you would expect the genetics to reflect this, the same pattern. So you would expect anatomy and genetics to reflect the same pattern. And that is exactly, not just more or less, it is exactly what we see. Exactly. And this is the way science works. You have a theory, you make predictions, you go out and make observations and see if your predictions are met. And if your predictions are met, as they are in this case, your theory gets confirmed. Not proved, but confirmed. And when you have made predictions in many different directions, here it is genetics, and we have talked about fossils, and we have talked about anatomy, and we can talk about biogeography if you want. We don't have time, but we could. And if you make all these different predictions based on the same theory, and you go out and look, and every single time you see exactly what you expect, then you are making science, and you are actually confirming your theory. And you are not making up dreams or hopes or faith or anything else. You are actually making science, even if you cannot see things working in real time. I don't. Do we have much more time, or did we? I don't remember how long time we agreed to go on. Did we say something like 1.5 hours, Mr. Hovind?
Yes, sir. Yeah, it's been 1.5 hours. Is that your closing? I can give a closing and we can quit.
Yeah, I think that was my closing then.
Okay.
Yeah, I just stopped the sharing here so that you can take over the picture.
Hold mine up, Steve. No. Okay. Well, thank you, Stefan, for doing this. It's obvious you really sincerely believe this. There may be a couple of reasons for that. Let's see. How do I? There. Get my screen share. Look at that. See? You would think this would all just happen just automatically, evolution. Okay. A couple of quick thoughts in closing. Fossils, and they're found all over the world, including the top of Mount Everest, are evidence of a flood. these animals drowned. In nearly every case, they drowned or suffocated or were buried in sediments so rapidly that they effectively drowned. Yeah, or suffocated or buried, compacted in the mud. So the Bible says in 2 Peter chapter 3 that the scoffers would come in the last days that would be willingly ignorant of the creation and the flood. And I'm going to have to put you in that category, Stefan. I think you don't want to see that there was a flood that formed all of these fossils, all at the same time. And flood would automatically sort them based on body density, based on habitat, based on intelligence. Any sorting in the so-called fossil record is best explained by a flood. We are a copy. It's obvious that you want to believe in evolution, and there may be reasons why. I don't know you at all, but I have in front of me a picture, a copy I made of Charles Darwin's book, page 217, about his confusion about the human eye. This was the first generation copy. I then took the copy and laid that on the copy machine and copied it again. And then I took the copy of the copy and laid it on the copy machine. I kept copying. Instead of off the original, I copied off the copy. There's the 5th generation. You can see the letters start to fade. There's the 10th generation. Much of it is now unreadable. There's the 15th generation. Very little of it is readable. In 15 generations, we went from a text that everybody can read to just about unreadable. Had we kept going, it would have been just a blur of everything. Every animal alive today is a copy off of their parents' genetic code. In the copying process, I don't know of any examples where new information is added. There are scrambled examples of mutations.
I can show you if you want to.
Well, let's do that next time. We got to go here, but if you have 1 or 2 examples, you would need trillions of examples to turn a bacteria into a whale. Trillions and trillions and trillions. Maybe you have 1, I don't know, but I do know that 99.99999% of all observed mutations are detrimental. It's backwards. It's sliding downhill. Now, maybe some people want to believe this, but I want to leave you with this one thought, Stefan. You and I both are going to die one day. You're going to be dead for an extremely long time, so am I. Are you sure, absolutely 100% sure, positive, that you want to follow this path of thinking that you're on? Because you're trying to deny, certainly you're saying God, the Bible is wrong, because it does not teach anything like you're teaching. And you're welcome to believe the Bible's wrong. That's your privilege. But you realize if I am right, this is Pascal's wager coming now, if I am right, you are in serious trouble. If you are right, I have not lost a thing. I have lived a wonderful life. I enjoy my family. I enjoy life. And I have, even if it turns out there is no God, I still had a great life on this planet. If I'm right, whoa, then the best is yet to come. And you are in royal serious trouble. You just might want to think about that. In the book of Romans, chapter 1, it tells us that people do not want to believe in God, so God gives up on them, and he lets them believe crazy things. Read Romans 1 very slowly and carefully. 3 times it says God gives them up to believe something absolutely silly. And, of course, it leads into, normally, it says in Romans 1, homosexual behavior. That is what the Romans 1 forget. So it starts with people not wanting God to run their life. So whether that's your case or not, I don't know. But you are going to be dead. I will see you Judgment Day. And I must tell you this. God loves you. He wants you to be saved. If you don't want that, then that's your business. But he does love you, and he wants you to get born again. But you have sinned. You're guilty. You've broken his laws. And you're going to face an angry God someday. I think your mic is still on over there, Stefan. Somebody's mic is. Okay. You're going to face a very angry God one day. And he's going to say the evidence was overwhelming, and you got millions of dollars worth of equipment to Judgment Day, and maybe I'll get over to Denmark, or you come over to Alabama. I'd be glad to take you to dinner, and we can talk about these things. But bottom line is, once we're dead, it's too late. So I would encourage you to really think hard. Are you sure you want to follow this path into the grave? Thank you so much for joining us.
Okay. Thank you.
All right, thank you for joining me again. Can you hear me okay?
I hear you okay.
Good. Now you are in Europe and you believe in evolution, and we said you get to go first to define what you mean, and I'd like to hear your side of the story. Tell us, in case people haven't seen any of our previous debates, tell them a little bit about yourself, what kind of work you do, what kind of education, and I think define the word evolution for us.
Yeah, okay. First, my name is Stefan Frello. I live in Denmark. I'm a teacher for 17 to 19-year-old young people. I teach maths, and I have a PhD in botany and a master in molecular biology. To define evolution, well, first, what we agreed on was the title of our debate was can the observed variation between closely related species be used as evidence that all living species are related through common ancestors? And
Correct.
that is what I'm going to argue in favor of.
Okay.
To define evolution, I think I have, yes, I have it here. First, evolution is biological evolution. I know that some people use the word in various different other ways, but I'm going to concentrate on biological evolution, which also is clear from the title of the debate. And it works more or less like this, put up here. Any organism will produce more offspring than will survive, and those offspring will be genetically variable. Some genetic variations will influence survivability and reproducibility. And the genetics of those with better survival, or rather better reproducibility, will dominate the next generation. This would result in an accumulation of variation over the course of many generations. And of course, in order for this process to go on, new genetic variation has to be supplied by mutations, because otherwise, sooner or later, the variation will disappear, and only one single type of organism will be left. But if we can show that new genetic variation can be supplied, then the process can it should be able to go on forever. The consequences of this is that accumulation of that there could be an accumulation of genetic complexity and of anatomical complexity as a consequence of the genetic complexity. And another consequence is that all living organisms are related through common ancestry. There are other mechanisms than natural selection, which was the one I described, and they influence evolution too, but natural selection is thought to be the only mechanism that can result in an accumulation of complexity. The other mechanisms is more a walk on the same spot, so to say, just adding variation, but not necessarily accumulating complexity. Now, natural selection do not necessarily result in an accumulation of complexity, but it will result in an ever better survivability and reproducibility of the selected organisms. So that is more or less the theory that I will defend, and just to make sure that we know where we agree and where we do not agree. You very often repeat this: dogs produce dogs, and all dogs had a common ancestor. It was a dog. And as a scientist, I would have to agree on that. All dogs produce dogs, and all dogs had a common ancestor, and it was a dog. There's no disagreement here. The disagreement comes in when we look at what happens on the long term. You often say we will never see a dog produce a non-dog. And within observable timeframes, I will have to accept and agree on that. Within observable timeframes, which is the normal lifespan of a human being or a few generations of humans, we will not expect to see a dog produce a non-dog. So actually, we do not disagree that much on this. It's not what can be directly observed we disagree on. It's more like what cannot be directly observed right now, but what can be inferred from the observations that we do. Because evolution, the theory of evolution says that from the observations we can do right here and now, we can infer that evolution actually has taken place and that genetic and anatomical complexity has actually accumulated. And if we go far back in time, then the ancestor of dogs were not dogs. And that is where the disagreement is, not on what we can directly observe. I also have to talk a little about what observation and evidence and confirmation actually is in scientific content, because direct observation of a phenomenon or a process is not necessarily a request as evidence. For instance, 350 years ago, it was well established that the Earth is orbiting the Sun, but nobody had observed it, and yet it was considered a fact. So that's just one example that direct observation is not considered a necessary request as evidence. And if we go just 100 years back, it was considered an established fact that matter is made of atoms, but at that time nobody had seen an atom. It is actually only in the recent time that there has been direct observations of atoms, and yet it was considered an established fact. Also, neither you or me or anyone else I know will dispute that fossils show that dinosaurs and numerous other extinct organisms lived on Earth. Nobody had seen a living dinosaur, and yet there's no doubt that dinosaurs were alive. So, just to stress it, it's not a necessary request as evidence that we make a direct observation of a phenomenon. We can infer it from indirect observations or of other observations that show that this process in question actually has taken place. Okay, so back to our topic. What should we expect to observe if the answer to our question is yes. And the question, just to make sure that everybody remember, can the observed variation between closely related species be used as evidence that all living species are related? See if I can hit it here. Yes. In general, the same kind of variation, we should see the same kind of variation, but not the same amount of variation at different taxonomical levels. We should find if we find a large amount of variation at the order or class level, I'll come back to that just in a second. If we see that, then we should expect small variations at the species or genus level. If we find large anatomical variation at the order or class level, then we should expect small variations on the species or genus level. And just to make sure that people are acquainted with the taxonomical levels, species could, for instance, be the wolf or the mallet, and representations of the genus. Canis lupus is the wolf, and Canis familiaris is the domesticated dog. The mallet and the teal is within the same genus, Anas. For the wolf is a member of the family Canidae, and so is the fox. The mallet is a member of the family Anatidae, and so is the goose. All carnivores, such as wolves and fox and cats, are members of the order Carnivora, and all ducks and geese and a few other birds. In this case, I have chosen the screamer, if anybody knows that. Is made of the same, is members of the same order called Anseriformes. And the highest level I have shown here is the class, very familiar, Mammalia and birds, called Aves in Latin. So what I'm talking about is that at the species and genus level, we should see the same kind of variation as we see at the order level, but at a much, much lower amount of variation. To make me a little more specific on what we should expect to observe, if the answer is yes, we should be able to identify mechanisms that can result in new genetic information. As you remember, if evolution had to be accepted as an ongoing process, there has to be some kind of mechanism that adds new genetic information to the genomes of the organisms. Otherwise, we will soon run out of variation, and all organisms of a specific species will be identical or nearly identical. So some kind of new genetic information should be added to the genome, and we have to be able to identify such mechanisms. We also have to be able to see a change in fitness, and fitness is defined as reproductive success. Because if there's no change in fitness, it means that all the members of a species has the same reproductive success. And if all members of the species have the same reproductive success, then there's no selection and hence no evolution. So some indication of variation in fitness should be able to be identified. Also, we should be able to see small anatomical and genetic changes and all kinds of small anatomical and genetic changes at the species level within historical times or within observable time. Those are the three topics that I'm going to talk about. We should not expect to see larger anatomical or genetical changes, and larger could be thought of as family level, which you hopefully remember. The family level is for instance, the wolf and the fox, and higher level of that should be, for instance, the wolf and the cat. Variation like the differences between the wolf and the cat, we should not expect to see that at the short time spans, observable time spans. But of course, there should be some change. If everything stays the same within historical time, then we cannot expect evolution to work. So these are my suggestions to what we should expect to observe, which I will show that we actually do observe, and what we should not expect to observe. And it's very important to make sure that you understand that we shouldn't expect to observe just about anything. We should only expect to observe minor differences. It's not the reason I have written this hopeful monsters is because it is a widespread misunderstanding that evolution could go in giant leaps from one species to a completely different species in one or very few generations, but that is not part of the theory. Okay, I have put up in the upper right corner the three main topics that I'm going to talk about. Okay, I shouldn't talk too much, too long. We should have a dialogue here, so I would like you to comment what I have been going through. Especially, what do you think we should expect to observe or not observe? Is the answer is no to our question, which I guess that you would say that the answer would be. And also, what evidence, if any, would you accept as or what observation, if any, would you accept as evidence for a yes to the question?
All right.
Okay. All right.
Thank you, sir.
Thank you, sir.
Hey, Steve. Steve, I'm getting a ring back. I'm hearing myself twice, getting a ring back here.
Oh.
Okay. Stefan, are you hearing it twice or just me? Oh, there, I stopped. It stopped. Okay.
I only hear them.
Okay. It stopped, whatever you did. You had about 20 minutes by my rough estimation here, so I'd love to go back through your slides and ask a few questions. You mentioned we should not expect to see any changes in the short term. This can
only minor changes.
Yeah, right. I understand.
Minor changes.
So you have to infer. I guess then I'd like to know your definition of science. Is this part of science, or is this? I would put it in the category of religion, but maybe you have a different word. We don't see any changes. It's my definition of science is things that are observable, testable, demonstrable. Can you, if you can't see, but you can only infer these changes, can you demonstrate? What if you chose a creature that had a much shorter lifespan? There are bacteria that have a 20-minute generation time. Why don't we see it there? Because with a 20 or 30-minute generation time, we're really squeezing the effect hundreds of thousands of years into one human observation lifetime. So, but we don't see it there either. All we see is bacteria produce bacteria, always the same species. What exactly are you claiming then is, you're claiming time is going to help. And that's what I've said all along in my teaching for 30 years on this topic, that time is the hero to the evolutionist. Time can accomplish, in your mind at least, what we can't observe and see. This is why I've continually said evolution is a religion that people believe in, but it's not observable. So let's see, just a couple quotes you had here. I think you said it cannot be observed, it must be inferred. And then you said, if we go back in time, Stefan, we cannot go back in time. It cannot be done. You can infer, you can think, you can dream, you can hypothesize, but the fact is we cannot go back in time. So if we don't observe dogs producing non-dogs in the 5,000-6,000 years of human observation, what are you hoping 5 or 6 million or billion or trillion years is going to do? And you never mentioned what is the mechanism that's going to add new information. To change from, say, a bacteria to a dog would involve billions and billions of bits of additional information. Bacteria don't have hair, they don't have a nose, they don't have a mouth, they don't have ears. Where's this information coming from? I'd like to see your mechanism to add information. I don't think any evolutionist has ever been able to demonstrate that it happens. They can imagine that it happens, they can hope it happens, and obviously they believe it happened, but that is not science. That is religion. You mentioned dogmatically in one of your slides that no one has ever seen a living dinosaur. I don't think it's logical or fair for you to make such a statement, because I doubt you've talked to everyone that has ever lived in through history. There have been thousands of reported sightings in history of people seeing living dinosaurs, only they had a different name for them depending upon their country. I cover this for nearly 2 hours on my video number 3. Dinosaurs that have been seen all through history, only typically called dragons would be a generic term. Dinosaurs that are mentioned, ancient artwork, ancient carvings on stones, stories by the thousands. Certainly dinosaurs as dragons are mentioned in the Bible 34 times. There's Behemoth and Leviathan. God said Job had seen this creature. He said he was living with one. Job chapter 40, verse 15. Behold now Behemoth, which I have made with thee. He has a tail like a cedar tree. And then there's all kinds of evidence, I guess anecdotal evidence of hundreds of people who will swear they've seen live ones in the last 100 years. There have been dead carcasses wash up on the beach. And let me ask you this, Stefan, if somebody captured an apatosaurus, a 20-foot long apatosaurus in the swamps of the jungles of Africa, and they put it in the zoo in Denmark, and you went there and looked at a living dinosaur, if somebody did capture one and put it there and let you come pet it and feed it and sit on it, would you then admit that the teaching of dinosaurs and man together is correct? Or would you then try to calculate some way how that one survived for 70 million years? And would you maintain your theory, your belief, I guess, that they died out 65 million years ago? I have been convinced for years that no amount of evidence, none, would convince a person such as yourself to change the teaching, to change the theory, the belief system that you have, because you really like it for some other reason, either because you get paid to teach it and that's a financial reason to continue that belief, or a moral reason, people don't like the idea of God telling them what to do, or a pride reason of they never want to admit they're wrong. But if one was captured and put in the zoo in Denmark, would you then believe in creation? Or would you then give up on the belief in evolution? So the key points I would like to make in my short time here, and I don't want to take 20 minutes, but you mentioned that it doesn't happen in observable time. It must be inferred. My point is, okay, great. That's not science. That's your religious belief. And then you said, if we go back in time, I would like to point out, Stefan, we cannot go back in time. You can't do that. So this, again, is a religious belief. I object to your statement that no one's ever seen a living dinosaur. And you said you're going to identify the mechanism to add new information. I would like to see that. This is, as far as my best count, my 150th debate. Congratulations, you're number 150. And I cannot find anybody who's ever been able to explain where added information comes from. How did the bacteria get the incredible amount of information to grow hair? Just getting hair to grow on anything requires something enormous amount of genetic information, the gene code. It would be thousands of lines of code in a computer necessary to cause this to happen, or to grow a heart or an intestine or reproductive organs or any number of things. We could go for hours and hours, but there would be billions and probably trillions and trillions of lines of code would have to be brand new lines of code in the DNA of the bacteria to change it from a bacteria to a dog. So I'll give you the time to answer these. I would like to know, where is the scientific evidence for these changes? Not only a mechanism. If you can dream up a mechanism, that's only step one. You now have to prove that it's actually happened rather than it's just imagination. So I would love to know, where is the mechanism for this to happen? How on earth could you prove no one's ever seen a dinosaur with all the anecdotal stories? And why would you think going back in time would help? We can't go back in time and go. All we've ever observed is dogs produce dogs. There are no exceptions. So I'm baffled, I guess, that you can continue to believe that it happened long ago and far away. We can't observe it today, even with something with a much shorter generational time, like bacteria. We don't observe it happening. All we observe is the changes that we do observe are usually detrimental or fatal to the organism. There certainly are none that I'm aware of that add new genetic information. So I do appreciate your faith and your great zeal for your belief, but this is not science. Okay, go ahead, Stefan.
Okay. Do you have my screen back?
I have your screen. Yes, your screen is up. Says the consequences of evolution.
Okay. Back to the evidence and confirmation. I think it is first on the dinosaur. If you could show me, or anyone could show me a living dinosaur, of course I would accept that it was a living dinosaur. But first, I don't accept all your stories. There are stories about mermaids also, centaurs, all kinds of different trend of animals, and all are stories. And if you look at how these dragons are described in different cultures, the Chinese version of a dragon is completely different from the European version of a dragon. So I don't think that's evidence of anything. And there are other, actually history is full of interpretations of observations that go beyond what is actually observed. As I mentioned, just two examples, that Newton 350 years ago was absolutely convinced that Earth was orbiting the Sun, though he had never observed it. I'm actually not sure that you can say that anyone has actually observed Earth orbiting the Sun even now. And atoms has been considered a fact for at least 100 years, perhaps somewhat longer, but only recently anyone had observed it. So this accept of phenomenon that you cannot directly observe is an integrated part of science. It was not a religion to Newton that Earth was orbiting the Sun. It was not a religion to Einstein that the matter was made of atoms. It has absolutely nothing to do with religion. And if you want to insist in that, I would like to hear you define religion, to give a definition of religion where evolution is a religion, but the orbit of Earth around the Sun was not a religion 350 years ago. I would really like you to give a definition of religion where this is accepted.
Would you like to?
No, okay.
Would you like to stop and do these one point at a time? I think people are going to get lost.
Yeah, perhaps we could do that. Yeah, we could do that. Yeah.
Okay, I think you're purposely muddying the water by saying 350 years ago the Earth orbited the Sun. It was established in Galileo's mind or whoever's mind, and that no one's ever observed the Earth orbiting the Sun. There are different levels of proofs, I guess, for any number of things. Certainly in the field of science, there are different levels of proof. There seems to be overwhelming evidence that we can quickly interpret to say, yes, the Earth orbits the Sun rather than the Sun orbit the Earth. For instance, in order for the Sun to orbit the Earth, to go around once a day, the speed would be phenomenal at 93 million mile radius, pi times diameter. I don't think it could move that fast. Whereas if the Earth simply spins, now you have the effect of seeing the Sun go around. So the Earth orbiting the Sun to take a year is very different than saying the Sun orbits the Earth in one day, which is what it would have to do. So I think we could do I think most people who've studied this topic would say it's pretty obvious that the Earth is orbiting the Sun. But you are right, no one's ever observed it. So that
and until 350 years, it was a well-established fact that Sun was orbiting the Earth.
That's an excellent point. The fact that something is a scientifically established fact in the textbooks or in society does not necessarily mean it's true. I would point out that the same thing is today. In your mind and in the mind of many people who have fields of science as their expertise, they think it's a scientific fact that evolution happens. Dogs came from an amoeba. They just don't understand how I can't see that. But you do believe dogs came from an amoeba if you go back long enough. I'll give you all the time you want. You can have trillions, quadrillions of years. Ultimately, to summarize it down into one sentence, I'm assuming I can speak for you and say dogs came from an amoeba-like creature, a single-cell creature. Is that what you believe?
Well, not an amoeba.
A single-cell creature.
I don't think that we should go into the details of the early evolution of animals, but it has actually been shown with some confidence that a certain group of unicellular eukaryotes are on the cellular level are almost identical to the cells of a sponge. They look almost the same. They have almost the same function. The basic difference is that in the sponge, all these different cells are grouped together in a single organism, and this unicellular organism is of course unicellular. Though once in a while, it also forms a colony of cells that works like a very, very simple kind of sponge. So actually that has been shown with in some details how the very, very early evolution of animals has been going on. But never mind. Do you have any?
Well, I just want to. I want to point out to the audience that you evaded the question. I said, Didn't
you ask me if we evolved from amoeba? And I answered.
Do you believe, just very simple, yes or no, do you believe animals, multicelled animals, like humans, do you believe humans evolve from a single-celled creature, whether it's an amoeba or not, a single-celled creature, in any amount of time? Yes or no? Do you believe that?
Yes. Yes.
Yes. Okay, good. And I point out, you are welcome to believe that. But that's not observable science. We observe amoebas and single-celled creatures multiplying all the time, in a very short generational time for most of them, and we never observe them producing anything else. So if you wish to...
Hey, can I show you?
Sure, please do.
Yeah. I see it's a bit down here. Here it is. Yeah, here it is. Yes, this one. Hey, what do we have here? We have two single-cellular organisms, one called paramecium and one called chlamydomonas. Chlamydomonas is the little green one with the two antennae, and the other one is the fluffy one. The fluffy one to the left is eating the little green one, but it can only eat it if it is unicellular. And it always is unicellular in nature. It has never been observed to form colonies in nature. But if you put these two together, then paramecium starts eating the little green one, which is actually an alga. And as a response to that, for the first time in history, it forms colonies. And those colonies are actually a little different when you repeat the process, which I have illustrated to the right. The bluish, I don't know if you can see it in the middle, the B column. There is a kind of bluish shadow around some of the cells, and that's one way of producing a multicellular organism. That single cells are grouped together, and there's a common membrane or the mutual membrane around all of them, and then they release single cell individuals which form new colonies in the same way. Or the colonies can be constructed by the single cells kind of gluing together and then releasing single cells that grow in the same way and form colonies. So this is the very, very first step from a single cell organism towards a multicellular organism, that the cells do not leave each other when the cell division is finished. They kind of glue together and form a colony. And the next one is going a step further. This is...
let's go back to that one if we could. Go back to that slide. Are you saying that a colony of cells is equivalent to an organism like a dog or a human, which has obviously maybe 100 trillion cells in a human, that they're working as organs, not as colonies now? This is very different. I think they're confused about a colony getting together for protection or for food production or something. We have all kinds of farmers get together in one community and have a colony of people. We had the American colonies, but they didn't ever refuse to become one human. They're still individual humans, and these are still individual cells. The fact that you have a colony of cells cooperating in a common goal, protection from the paramecium in this case, is not evidence that they can become a single organism, like the humans are still producing humans, even though they have colonized together thousands of times. So I think you're very misleading in your illustration here. If you're misleading the audience to think that this is a step toward multicellular organisms, no, this is a multicellular colony. Please don't confuse the two. This is not evidence for evolution.
But what would the very first step from a unicellular organism to the multicellular organism? It had to be a colony of identical cells. It had to be the first step. What other step could be the first step? If
that's
not
a great point, Stefan. This is evidence that you have great faith that something did happen, and you're looking desperately for the steps of how it happened. But that's not science.
Looking right at the first step.
No, there are three things.
And if you will allow me to show the next one, I'm looking right at the next step.
Well, let me finish with this one. Let me finish with this one first. I don't want the audience to think that you're correct on this one. There are single-celled organisms, millions of them. There are single-celled organisms that work as colonies. That's very different. They're very different than a multicellular organism. You're assuming the colony is a step between the two. I completely disagree. This has not been demonstrated in any laboratory anywhere because you have to get a huge amount of new information. Each one of those cells that came into that colony had a gene code to make a cell just like itself, or with a few minor variations. None of these cells in this contain the genetic information to make hearts, livers, organs, skin, toenails, hair, teeth, eyeballs. Okay, and they're never going to get it. There's no new information in that colony. There's a new cooperation, but there's no new information, no new genetic information. So you're deceiving people to say that that would be a step to go from single cell to a multi-celled organism. The colony is totally separate, unrelated. That's a rabbit trail you're leading people down. Go ahead to step 2, but I'm going to strongly disagree on your step 1.
Okay, but if there is no new genetic information, why do they stick together? What makes them stick together? What makes them stick together if not a change in the genetics?
Was there a change in the genetics?
If the genetics is still exactly the same, then why do they stick together?
It was in their genetics all along to stick together as needed.
No, it wasn't. No, Mr. Hovind, it wasn't. It has never been seen before. Never.
Has anybody seen new genetic information that tells these single cells to join together to a colony? There are people all over the world who are individualists, like Daniel Boone, go out across the wilderness by yourself. And yet most of the people want to get together into a colony, like the New England colonies that came over here mostly from Europe. But they're still individual human beings. The human beings never grew together to be one 5,000-ton animal or creature. They're always individuals in a colony cooperating. All you've demonstrated is the cells can cooperate for a common goal so they don't get eaten by the paramecium. That's cooperation. That's not accumulation of new information.
But why do they cooperate if they still are identical to the original one-cell organism?
Yeah, so they don't get eaten. Why do people colonize and get together so the enemy doesn't in a wartime? Why do they form armies? An army is not a single unit. It's not one organism. It's a group of individual humans.
So what you are saying is that these single-celled algae has some kind of individual goal that we don't want to be eaten, so let's cling together.
Oh,
nonsense.
I have no idea.
You are constantly comparing them with humans.
I have no idea what they're thinking. But
they don't have a goal. They don't have a brain.
Right.
All they have is the genetics.
You have not demonstrated that there's any new genetic information, and you've not demonstrated that this is a step toward a multicellular organism like a dog or a human. That's a colony. Don't confuse people with trying to say this is similar. It's not similar. This is not a step. You have no link. Where are the two-celled organisms in anywhere in biology? You have a master's in biology and a PhD in botany. Where are the 2 or 3 or 4-celled? There are none. The closest we get is a colony of maybe 20 cells cooperating together for some reason. But again, each cell contains the same original genetic code. And I would say in a court of law, Your Honor, you cannot demonstrate that the individual cells don't already have something in their gene code to say, oh, if we're getting threatened, join together. Just like people, when they feel threatened, they go huddle together and make themselves an army or a colony or a kingdom. That's not evidence for evolution, Stefan. Stop deceiving people. Go ahead, step 2.
These single-celled organisms don't know that they are chosen, that they are going to be prey for this predator, not before they are eaten.
Does the single
They are swimming happily around in the water, and then suddenly, shoop, they are gone. They are not warned in any way. It's not that they can foresee that, oh, we are going to be eaten because this paramecium is swimming around here, so we have to do something. That's not what's happening. Either they are eaten or they are not eaten, and that's it.
Let's take one topic at a time. So, does the single-celled algae have an escape mechanism? Does it have a mechanism to sense danger? Why does it flee? When the paramecium comes to the algae, does it lay there and let it be eaten, or does it try to evade being eaten in any way? Are those two little hairs on the algae, are they actually a flagellated flagellum that can spin, that allow it to swim away? I think you'll notice
I don't know if it has any of the paramecium.
Get a microscope that can view down to single-celled organisms. If an enemy comes in, almost all single-celled organisms have A, a method of detecting their enemy, and B, a method of trying to evade their enemy. None of them lay there and get eaten, or they would go extinct. All of them have some method of protection. So you're saying they just colonize for no reason. No, I think maybe they have a reason. What they think, I don't know if paramecium or these creatures think at all, but apparently they do have some kind of mechanism already built in the gene code to detect a predator or a danger and to evade it. I think it's been demonstrated thousands of times that some can even change their coating on the outside if a particular chemical is present in their environment. They will learn to protect themselves by developing a shield around them. This is not adding new information. This is a selection of information already existing in the gene code. So to go from a single cell to a colony is not going to help your theory. But I know you believe it and you want to believe it. But it's not science. This is your religion. I'll stick by that. Anyway, so you think the colonies are is a step between single cell and multicell. I completely object. That is not correct. But go ahead. What's your step 2 going to be?
Well, first I have to stress that this has been repeated several times, and at least some different mechanisms has turned up. The column B and C shows 2 different ways that these cells protect themselves. So this points rather to new genetic information than to some pre-existing mechanism. But this step 2, the natural step 2 in the course from a single-celled organism to a real multicellular organism would be first to form a colony and then to initiate some kind of cell differentiation. And the very first steps towards cell differentiation is illustrated here. I have to explain what's going on. They have selected for colonization by growing these fungi, it is, in water that is not shaken, so that the cells would settle, and colonies of cells would settle faster than single cells. And by sucking up the cells that were in the bottom of this this tube, they got an enrichment of colonies of cells. And when they observed them, they observed something quite extraordinary, because they actually observed cell differentiation. They were able to stain these cells in various ways, and by doing that, they could see that the cells were actually behaving differently. It is illustrated here by some of them being blue and some of them being green. And it turned out that the cells that were different from the majority of cells actually were those that later died and caused the colony to separate into several colonies. So here we have the first step is colonization from single cells to colonies. The next step would be the very first initial steps towards a cell differentiation. And what we see here is actually cell differentiation. Some cells die, which helps the colony of cells to divide into separate colonies.
All right.
And this is not just a second, and this is actually beneficial for the cell colony, because a large colony of cells would the nutritional supply to the cells in the middle of the colony would be less efficient than if the cell colony divide into separate colonies and then keep on growing. And that is what we see. And what the major point here is that they could identify the cells that later would cause the colony to separate into separate colonies. They could identify them several cell generations before it actually happened.
Okay, let me give my answer to that. Obviously, if there's a cluster of cells that have colonized, the ones in the center are going to get less nutrients, we would assume, because they have less contact with their environment. They're surrounded by other cells and they can't eat, sleep, breathe, or poop. So, of course, that's the place where the colony is going to separate. Those are the cells that are going to die and no longer cling to other cells. But again, I would point out that cells getting together and colonizing, and then even differentiating, whereas different ones have different functions in the colony. In the American colonies, people came over, they settled, and very soon after they got the basic needs met, some became farmers, some became bankers, some became cooks. They had different activities, different specialties that they would, but they're still individual humans. They never merged into one 10,000-ton human being. They were each individual people in a colony. All you've demonstrated here is the same thing. A group of cells can get together, and maybe one is better at taking in a certain substance that the colony needs for survival. One may be better for defense, but they're still individuals, and I would point out that you've not demonstrated that this could not already be in the gene code. There are individuals who can live completely on their own, completely. They can go out in the woods and survive on roots and berries and catch animals, but if they join in with a group of other people, pretty soon they take on their specialty of maybe they're the marksman shooting game or the gardener raising crops. They're capable of living on their own, but they're also capable of living together with others. What you've demonstrated here is single-cell organisms are capable of living on their own, or they're capable of living in a colony. And if they get too big of a colony, the ones in the middle are going to die and hence break the colony at that point. So yes, I would think that's probably scientific and logical that you could look at a colony and say, that one's going to die and this is where it's going to split. This is not evolution. This is no help for your theory whatsoever.
Oh yes, because they could identify the cells long before the colony actually grows so big that the cells were in any problem of nutrient supply. But I think we should leave that. We will not agree on this. So we can just agree on disagreement. Okay. I have presented the evidence, and you have made your comments. Back to the mechanisms for adding genetic information. You were asking about mechanisms for additional genetic information, and I just have to see if this will follow. Yeah. Just have to point out the right place. Here we are. Creationists often claim that no known mechanism can add new genetic information, but if you look at the scientific literature, there are actually several known mechanisms that can add new genetic information to an existing genome, and I'm going through a few of them. Within the last 2 decades or so, it has appeared to scientists that actually there is brand new genes called de novo genes or orphan genes, which appears from non-coding DNA. So you have a protein coding gene where no protein coding gene was in the ancestors of this.
Okay, hold it. Let's take it. I want to take these one at a time so nobody gets confused. Are you saying there were new genes that came from non-coding DNA? Was this new information added to the DNA or silent genes that were activated that were already present? Are you saying there was new information added or just a something that was normally non-coding all of a sudden started doing its job? Someone came off of welfare, in other words.
I think I have to explain how these were identified. I think that would answer your question, if I may.
Okay.
May go through that. Just to make sure that that our audience are familiar with what a gene and what a protein coding gene is and how it works. DNA is built of nucleotides. It's this well-known double helix structure, and all the little balls in the middle there are representing the so-called nucleotides. There are 4 different nucleotides called, normally abbreviated A, T, C, and G.
Right.
And the function of a protein coding gene is that the DNA is transcribed into a so-called messenger RNA molecule, and that molecule is translated into a protein. It's a complicated mechanism, of course, but that's a short story of it. And it is the protein that has the function. The gene itself, the DNA gene, doesn't have any other function than being transcribed and translated into the protein. And it's a protein that actually has a function. This is going on by taking 3 nucleotides at the time and translating it into 1 amino acid, and a sequence of amino acids then builds the protein. So it is the sequence of amino acids that decides decides what the protein will be doing. We'll skip this one. Then identification of candidate new genes. This is, I think, what you were asking. How do we identify a new gene?
No, I'm asking, not is it a new gene? Is there new information added, or is it a scrambling of existing information, or a gene that came off of welfare and decided to get to work now?
Yeah,
it's already there.
This is more or less the same. What people have been doing for identification of these new genes, they have compared a number of very closely related species, and often it's species within the same genus. Often they have been using Drosophila, coming right up there. Drosophila is a fruit fly.
Right.
And there are a large number of, a very, very large number of Drosophila species, and I think that we can agree that they had a common ancestor, which was a Drosophila fly.
Fly, yes.
Just to make sure that we know what we agree on. And then a number of these different Drosophila species have been analyzed in very, very great detail. The most well-known one is Melanogaster. That's the one that has been used for genetic research for decades, or almost 100 years now. And in Melanogaster and its closest relatives, or the species closest related to it, researchers has found a number of protein coding genes that are not present in any other Drosophila species. And there's a very, very big number of Drosophila species that has been investigated here. So the simplest explanation is that these genes actually occurred in the common ancestor of Melanogaster and its very, very close related species, and that it is not a gene that has been lost in any of the other species. It has never been there. It has been the sequence that make up this gene is present in the other species, but it is not an active gene, and it has never been an active gene. It's not a sleeping gene that just waits to be activated. It's a sequence that is not that doesn't have the right signals for being translated into a protein. Actually, what they did in this particular investigation here was that they were able to identify the so-called stop codon. If I go back a few slides here, a protein coding DNA sequence is defined by its start codon, which always is ATG, the start codon, and then a number of amino acid defining codons, and then a stop codon. And between those two is the protein, to tell the story very short. And what they were able to do in this investigation, in this slide, come on, here, and no, this one, this one, and this one. Those two are both Drosophila investigations. And what they were able to do is to identify the mutation that removed a stop codon in the middle of this DNA sequence, so that instead of a stop codon, you have an amino acid defining codon, and then what was a non-coding DNA sequence suddenly was turned into a coding DNA sequence, and now the protein was able to be translated and function. So if that is not new genetic information, I don't know what you are asking for.
Okay.
This is a protein that is produced in some species that has never been produced anywhere before. They have tried to search the entire gene bank, which comprises millions and millions of DNA sequences from hundreds of thousands of different, perhaps not hundreds of thousands, but tens of thousands of different species. And they haven't found one single example of this particular protein in anywhere. So it is a new protein.
Well, it's a new protein, possibly. Let's discuss this for the listeners here. What the stop codons would be similar to a period when you're writing the English language, and I'm assuming it's the same in Danish or Dutch or German or French. You have a sentence, a single thought, and you put a period at the end, and now you start a new thought. If by accident one of the periods was taken out, you would put two sentences together and get in English what we call a run-on sentence, which now may give a little slightly scrambled information to the person trying to read it, like what does this mean? So I think what you've done is you've discovered that in a certain few cases with the Drosophila fly, the stop codon, the periods were removed, and it developed a run-on sentence. And they're calling that a new protein. Okay, let's call that a new.
They're not calling that a new protein. It is a new protein.
It is. It's a new protein.
You have to understand this. Before this stop codon was removed, there was no protein. No protein was produced.
Right.
Only after the stop codon was removed, a protein was produced.
I would like to point out that this is not new information. The information was already there. It is now scrambled into a run-on sentence. And I'd like to point out, it is still a fly. In every case, it's I mean, are you telling me there's been examples where it turned into something that was non-fly?
May I remind you, Mr. Hovind, that at the very beginning of this, I said that, yes.
Have to wait longer. More time.
In observable time frame, we will not expect to see a dog produce a non-dog. That was what I said, and you insist that that is what we should expect to see. Actually, you insist that in order for you to accept evolution, we should observe what the theory of evolution says that we should not observe. That is nonsense.
Okay, I am pointing out for the listening audience here that what you've given us is an example of removing a stop codon, creating a new protein, which I will give the analogy of a run-on sentence, which would be a whole new thought. Two sentences run together, like, well, it's a new sentence. I agree. It's not new information.
The information before that new sentence was not two sentences. It was 2 times nonsense.
Right. So that is not a mechanism that's going to change a single-celled organism to a human. This is not observed, and you fall back on your God, which is time. Time can somehow solve it. This was a loss of information. Have any of the flies that have been observed to have this new protein, first of all, have any of them been an improvement over the fly? Secondly, who are they going to marry? Or is this new protein going to be lost in the next generation? Because you'd have to have two, a male and a female, in the same place at the same time. and be interested in each other, you've got a host of problems. If this happens once by random chance in one fly gene code, how's this going to get passed on? Has it ever been demonstrated that it gets passed on? And is it new? Is it helpful to the organism or harmful? They've got flies that are blind, flies that can't fly, flies with curled wings. They don't get an improved fly.
Well, actually,
you believe it.
Some of these identified new genes actually has been proven to be essential to the fly. Probably because it has lost some other gene and this new gene has replaced it, or because some other function has developed in or had evolved in the fly so that it became dependent on these genes. So actually some of these genes are now essential to the species where they are found. So yes, it is actually new information, and the fly has changed. It's a new species. It's not a non-fly, which you should not expect it to be. It's a new species, which is what you should expect it to be. And just to make a little, well, what do we see here? There's a number of pictures. What do we see?
I see a variety of dogs, but let me point out.
No, you don't. Mr. Hovind, no, you don't.
Oh, okay. There's a panda bear in there. There's a panda bear.
No, it's not. No, it's not a panda. That's a dog. But the one to the left is a cat.
Oh, okay. But Stefan,
apparently, Mr. Hovind, apparently cats and dogs has an overlapping variation.
Whoa, they both have two eyes, and they're both affected by gravity. That proves it. Stefan, hold it. We started late because of the technical problems, and I apologize. I'll do this again anytime. I have another debate, so we have to stop in about 15 minutes, and then I have to stop. I have another debate already scheduled. So yes, good. You got a cat with long hair that I mistook. I just glanced at him, mistook it for a dog. That's, I think, evidence that the same designer made them. Some people confuse the Porsche and a Mercedes. You know, when they go by at 200 miles an hour. Well, what was that? Well, they both have 4 tires. They got to be related. No, it's the same. It's a common design, and I don't think I'll ever get you to see that. But I want to go back to your fly illustration. You're getting a new protein from this stop codon being removed. It is still a fly. You still have a problem of this being passed on to the next generation. And where is the example of an improvement of changing to anything other than fly? This isn't help for your theory.
We shouldn't see anything other than a fly within historical time.
So because we don't see evolution happening, that's proof that it happened.
No, we see evolution happening. We see new genetic, new proteins, new protein coding genes appearing at these flies, and we have seen them all over the place. It has been. This is another example of Drosophila. This is humans. This is mouse and rat, and this is fungi and mollusks and tardigrades and nematodes and plants. It has been found all over the place. And Mr. Hovind, this is actually the mechanism that you were asking for, because if within a time frame that is short enough for an organism still being in the same genus, like the Drosophila here. Drosophila is what we normally call fruit flies.
Right.
Within Drosophila, we have several examples of new genes. 195 new genes has been identified in various Drosophila species. Just think for a second. If 195 new genes can emerge within a single genus, then how many thousands can emerge within a family or within an order? And that is what you are asking for. New genes that change the genome of the organism. And we see it right in front of us.
Hold it. You're moving the goalpost here. Let me ask you this. I'm just maybe totally unable to give the information. How many genes are there in the fly's gene code?
About 20,000.
20,000. So
yes,
you're
so
saying
this is actually 1%. This is actually about 1% of it.
So out of 20,000, you're saying 1% of the genes have been modified through losing a stop codon. Again, they're losing information, they're not gaining information.
That's nonsense. Losing a stop codon is not losing information. It's changing one nucleotide into another nucleotide so that a stop codon turns into an amino acid codon. It's not losing information.
And are you convinced that that mechanism you just described of losing a stop codon and creating a new protein, that is the mechanism that is going to, over trillions of years, going to change a single-celled organism to a human and an elephant and a whale? Is that what you believe? This is the mechanism that will do it?
Plus a number of other mechanisms.
What other mechanism?
Well, we don't have the time for it, but I have a number of slides showing other mechanisms too.
Go ahead.
There are plenty to take up, but if you think about it, 1% within one group of organisms that are so closely related that even you would accept that they had a common ancestor.
Right.
So if you just for a short second accept that this could be extrapolated to family order, then you would not have 1%, you would have 10%, 50%. You would have almost all those genes that are not essential for the very basic biochemistry of the animals. Okay.
Let me give an example. When they first started the Olympics, I think 1930s or something, Hitler revived the Olympics idea. We could look at the top speed of people running, and let's say someone could run the 100-yard dash in 10.5 seconds. Over the last 70 years, they've got it from 10.5 down to under 9 seconds now, I believe. If in 70 years we can knock off 1.5 seconds, does that mean if we go 700 years, they can knock off 10 seconds and go down to 0 and run the 100-yard dash in 0 seconds? Is this logical, or is this stop codon, is this new, this protein mechanism that you just described, could it be that that has a limit? And you got 195, maybe they're only going to get up to 250 and something's going to shut it off, or the fly is going to die. You haven't demonstrated, other than imagination, SpongeBob, that maybe if we give it more time, there's your God, it could do it. This isn't science to say that. You can't go back in time. We can't go forward in time. All we've observed in all of human history is flies produce flies. If you want to say they have new information, did the fly get something different than a wing, or did it get a new structure? It had a new protein. What good did this do for the fly? Can it fly faster? Can it produce more offspring? What beneficial mutation has come from these 195 new genes in the fly out of the 20,000? Have you demonstrated any new information that's helpful to the fly?
Well, as I said, a few of them have actually turned out to be essential for the survival of the fly. I don't know if they have been analyzed so that people know what they actually do, but they have been demonstrated to be essential for the survival of the fly. So in some way they are very, very important, some of these.
Well, now hold it. Are they essential to the survival of the fly because it is now encountering some new environment, like some man-made toxin or poison, or something in the atmosphere or the food? The world is constantly changing, sometimes man-made, sometimes nature-made. But did the fly ever get a turbocharger? Did he ever get a jet engine, or is it still a fly?
As we should expect under the theory of evolution, it is still a fly, yes.
Hold it. As we should expect under the theory of creation, it is still a fly. Creation predicts that also, by the way, Stefan. Creation predicts animals will always bring forth after their kind, and a fly is the same kind of animal as a fly. So this is predicted by the creation model, not by evolution.
I would love to discuss phylogenetics with you and show you why phylogenetics is not, as you describe it, just lines on a piece of paper, but that it is actually very, very well founded in observation, because that would be what you are asking for. How do we know that different animals are actually related? What are the evidence that organisms or animals that you would say were different kinds, even though you have never been able to demonstrate that you actually know what a kind is. On the contrary, you have been contradicting yourself all the time on that, showing that well, I have to be blunt with you. You have been showing that you have no idea what you are talking about when you mention the word kind.
Okay,
But,
and
back to the question of this.
You have no idea what you're talking about when you mention the word evolution. You have no idea what you're talking about when you talk about animals producing new information. That was not new information. It already had the sequence of letters. It removed a stop codon. It happened to make a new protein, but the information was already there. You didn't add anything to the gene code. You have no clue what you're talking about. Now, we only have 6 minutes left. Can you give a summary of your position? We'll do another debate as often as you would like. We'll do this every day if you'd like, but I ran out of time. So give me, you said at the beginning, and I pointed out, that you said, we don't observe it over the short term, and we should not expect to observe it over the short term. Okay, so therefore, my point is, this is something you believe in. You don't like the word believe, but that is very much what you believe in. So do you have one more point you'd like to make, or maybe a closing, or draw your pieces together? You're saying removing stop codons and creating new proteins in Drosophila fruit fly is enough evidence to make you believe that flies are related to bananas and elephants.
No. Well,
okay.
If I was going to present all the different arguments in favor of evolution, it would be a 2-hour non-stop speech or something like that.
Okay.
If people are well, you really have to. I don't know what to do for comprising the evidence into a reasonable time. But I think we should conclude this, because you have to.
Yes. Please do. Go ahead. Give a closing. Give a closing here, and we'll take up round 3 later.
Yeah. Okay. First, I have to stress that that it is not a necessary request of evidence that a phenomenon is directly observed. It is sufficient that you have that you can say, well, what we see is what we should expect to see if this phenomenon was actually occurring. But the phenomenon itself is occurring over a very large amount of time, so we cannot expect to see it. But if this phenomenon, evolution, occurs over these large spans of time, not trillions of years, as you said, but up to, I think it's about 600 million years is the time frame for animal evolution, or perhaps a little more. And if animal evolution has been taking place for 600 million years or a bit more, then what would we expect to see? And one thing we would expect to see is new genes going into the genome of organisms by whatever mechanism can make new genes arrive. And that is what I chose to show you here, that process has actually been established. Several other processes for adding new information to the genome has been established too, and I would love to continue this and show you. But what we have to appreciate that the phenomenon does not have to be directly observed in order to be a scientific idea, or even to have to be a scientific, well-established theory. And that would be my concluding remark.
Okay, very good. Thank you, sir. And let's do another one here. What would we expect to see if God created basic kinds of animals, gave them a phenomenal gene code, the ability to produce a wide variety within that same code, big dogs, little dogs, long hair, long legs, short legs, but always a dog? What would we expect to see? I think we would expect to see bacteria produce bacteria, flies produce flies, but dogs produce dogs. I think that's not only what we would expect to see, That's what every farmer on planet Earth for all of human history will record. That's all they have ever seen. So not only do we have, I think, the common sense expectation on the side of creation, we have all of observation. All human observation says animals were created to bring forth after their kind. Any scrambling of the information usually results in a mutant, which is harmful or fatal. Many of them, of course, cannot reproduce, and you have to have, if you're going to get a beneficial one, which has never been demonstrated, you'd have to get two at the same time of the opposite sex in the same place, and they now would have to not only take over the population, all the rest have to die, or it doesn't work. Evolution is a religion of death. Everybody has to die who's not fitter. This is Adolf Hitler 101. These are the unfit, let's kill them off. The fit need to survive and take over the population. You folks in Europe are very familiar with that. So you say it does not have to be observed. I point out, Stefan, it isn't observed, and you believe it, and I appreciate your faith, but it's not science. And thank you for coming. Let's do another one. If you can call my secretary, I do have to go. But you want to give folks your contact info if they want to get a hold of you? Stefan, do you want to give people your contact info?
Yes, it is stfr at hotmail.com is my email. Feel free to write any question to me, and this slideshow I will put it on my homepage. The address of that was on my very first slide. This one here.
Yeah, call that up.
Evolution and some strange number.
There it is.
It will be there in a few days.
Creation via evolution.dk/43647744-2. Okay, well, thank you so much, Stefan. Let's do another one, and I'd like to see what other evidence you have for evolution. Appreciate you coming on. Thank you.
Thanks. Bye.
Yeah, there you go.
Oh, all right. Looks like we are, well, alive might be kind of a strong word.
Yeah.
Good to have you back, Stefan. This is Kent Hovind from Lenox, Alabama, where we're building Dinosaur Adventureland, a museum, science center, theme park, all based on science and the Bible. And Stefan is with us from Denmark, I believe, and you are going to continue the discussion we had last time on creation versus evolution. So, Stefan, tell people a little bit about yourself, who you are, and what you do. And I think it's your turn to go first, isn't it?
Okay. My name is Stefan Frello. I am a teacher in math for 17 to 19-year-old young people that are about to attend university. What education they're doing together with me. The only topic I teach is math. I'm not teaching biology, but that is for some technical reasons. Our discussion today should be about, well, that is on my first slide. Should I put that on?
Sure. I've got part 3, I think is what it says. I got your slide showing right now.
You have my slides showing right now. Okay, so I
Yes.
just have them on my screen too. Yeah. It's the same topic as last time, as you mentioned. Can the observed variation between closely related species be used as evidence that all living species are related through common ancestors? We're going to continue on that. When we are finished, I will put this presentation on the mentioned webpage, and my contact address is also there if anyone should feel like asking me any questions. Our previous debates, we have had 2 of them, one early this year and one in September, and I put the links to them there too, if people are interested. There is a few topics that we talked about last that I just want to close. We shouldn't discuss it a lot, but just to close them. You mentioned more than once that new genetic information has to appear simultaneously in a male and a female, and that is simply not true. It doesn't have to, and I'll explain why. And also, you call the theory of evolution a religion, which you always do, and I will show you why that is not true either. And then you, of course, had to mention Hitler, which you always, or no, or not always do. That's not true. But once in a while, you mention Hitler, and you want to stress that evolution is a very bad ideology, as you put it. Then I have looked into some of the details of one of the examples that we discussed last, and I'll just close it shortly. And then you claim that there has never been described a mechanism that can add new genetic information to an organism. And that is actually what I'm going to concentrate on in this debate, such mechanisms, because they are very well known and there are a number of them. There are some people talking in the background.
Yeah. Hey guys, he can hear you. Nick. Yeah. He can hear you on the mic. Right down there.
Okay. Yeah. Okay. First, you're saying
he can hear you talking. Oh, the door shuts. Okay, go ahead.
Yeah. Okay. First, why two simultaneous mutations are not needed? Well, I have illustrated this with these little living and dead birds. The two bars represent the genome, two sets of chromosomes. The little red dot in one of the birds at the top is representing a new beneficial gene that occurs in a single copy in a single individual. And we discussed that last time, that new beneficial genes actually do occur here and there. Not very often, but they do occur. And if people are interested in that, they can go back to our discussion from September, following the link in the very first slide. Now, if that is actually a beneficial mutation, and if it is dominant, which it will be if it is a new gene, because there is no counterpart, then it will be dominant. And if that is the case, then it will have a tendency to spread in the population. Not very fast, and often the carriers of this new gene will die, but all in all, they will have a better chance of surviving if they are carrying a new beneficial gene. If they are carrying a new harmful gene, of course, they will have a higher tendency to die, and the harmful gene will disappear from the population. But if it is beneficial, it will have a tendency, or can have a tendency, to spread in the population, and sooner or later, two individuals each carrying one gene will meet, and an individual with two copies can come out of that. And in this way, a single mutation in just one copy in a single individual, actually over the course of course, many generations, can spread throughout the population. Normally that would only happen if the population is not too big, but it is possible. Now, that was the first thing I want you to comment on. The second thing is this religion thing. In your debate with Aaron Ra in March 2018, I'm sure you remember that, it was very lively, to say it mildly. You suggest the following definition of religion: a set of beliefs concerning the cause, nature, and purpose of the universe. That was your suggestion for a definition, and I put the link both to the discussion and to this definition of religion. They are in the left corner. But biological evolution doesn't talk about either cause nor purpose of the universe. It talks about the nature of a very tiny little part of the universe, that is the living organisms, but nothing about the cause, nothing about the purpose. And therefore, by this definition, evolution is not a religion. So I think what you have to do is the following: either you have to accept that theory of evolution is not a religion, or you have to suggest some other generally accepted definition of religion and explain why you would prefer that instead of the one that I have highlighted in red, and why you think that this new definition that you might suggest will have the consequence that evolution is a religion. Now, actually, I will predict that you will do neither. I don't think that you can argue that the theory. I don't think for a minute that you will admit that theory of evolution is not a religion, and I don't think that you can come up with another definition of religion, which will have the consequence that evolution can be said to be a religion. I don't think that you can do neither. Then we have Hitler. You mentioned Hitler as an example of how dangerous the theory of evolution is. I have found, well, you do this once in a while, but the first time I heard it was in a video called 100 Reasons Why Evolution is Stupid, and I have put the link down there. And from that, I have this quotation where you say that Adolf Hitler was a strong believer in evolution. He thought that the Jews were an inferior species that needed to be eliminated from the group of humanity. And well, the consequence of this is that you actually apparently think that we should trust this notorious gangster. I don't think we should. But if you think we should trust him, then it has some very, very strange consequences, because according to the Nazis themselves, they were Christians. According to themselves, they were doing God's work. So if we are to trust Hitler, then, and we have to accept that he was a strong believer in evolution, then we also have to accept that he was a Christian who, in his own mind, was doing God's work. And the reason that we can know this is that I have copied a picture of the belt buckle of the Nazi soldiers, where it said "Gott mit uns," which means God with us. So in their own minds, either they were simply lying, which I think they were. They were lying about evolution, they were lying about being Christians, they were lying about everything. But if you think that we can trust them, which you apparently do, then we must trust that they, in their own mind, were Christians doing God's work, which is, of course, equally absurd as the idea that Jews were an inferior species. And the story about this single-celled creature called Clavidomonas, which apparently turned into a colony-making creature. This is referring to an example I used in the previous debate, so if people have interest in this, they should go to the very first slide and follow the link to our previous debate from September. The story is that these little green creatures, the small ones, are eaten by the fluffy, larger ones, and when they are grown together in a population with both organisms, the small ones tend to produce colonies to defend themselves because the larger fluffy one can only eat them one by one. And when they form a colony, they cannot be eaten by the fluffy one. You argued that we could not know whether this ability to form colonies was already in the genome of the little green algae. And the way I presented it, I had to admit that you were right. We could not know the way that I presented it last time, but I looked back into the paper to see if that was really the case. And it turns out that there were several good arguments that it was not the case, that this colony forming ability was actually due to new beneficial mutations occurring in the green algae during the experiment. And the argument goes as follows. First, the colonies didn't form immediately. If the ability to form colonies was already in the genome of the algae, then you would expect them to form colonies quite fast after they were attacked by the fluffy paramecium. But they didn't. It took several hundred generations before the colonies started forming. That's the first argument. The second argument is that these investigators investigators actually had 5 identical populations of these creatures, and only in 2 of them we saw this colony forming thing. If that ability was already in the genome and the populations were identical from the beginning, then you would expect colonies to form in all 5, and you would expect these colonies to be more or less identical. They need not be completely identical, because it can be difficult to control the environment completely so that you get exactly the same result. But they should be more or less identical, and they should appear in all 5 populations, but they didn't. And they should appear quite fast after the attack from the paramecium. But they didn't. It took several hundred generations. Only 2 of 5 populations showed this colonization, and the 2 examples were very, very different. In one of them, the cells formed an extracellular matrix that kept them together and defended them against the paramecium. In the other, the cells simply stuck together. Instead of spreading and leaving each other after cell division, they kept sticking together and formed these colonies. So the ability to form colonies clearly is due to mutations occurring during the experiment. Another thing is that after removing the paramecium from the medium, the algae kept forming the same kind of colonies for several thousand generations. So it was a very stable phenotype. Right. The last part of our, or the remaining part of our discussion should be about this ability for organisms to develop new genetic information, because it is certainly a request for evolution to go on that this should be possible. If no new genetic information can be constructed or be added to the genome of an organism, then evolution would very, very soon come to a halt, and you wouldn't get anywhere anything else than just bacteria. They could never develop into or evolve into anything else. But there are actually a number of different possibilities for adding new genetic information. And I must say that when you say that you have never heard anyone showing a mechanism that can add new genetic information to an organism, I must say that you are willingly ignorant, Mr. Hovind, because it is so easy to find this information. All you have to do is simply Google new genetic information. You get a number of links, and each of them will probably help you. I chose a little video here and with the snake up in the corner, and in a few seconds I got this list here down at the left corner, known methods of gene production. One of them is called gene duplication events. And then you could say, well, that's not a very good argument, because this is just some amateur making a video, and that would be absolutely correct. But if you then use gene duplication as the next search word, you can get thousands of scientific papers, real scientific papers from peer-reviewed international journals, like the ones that I have copied here from Nature and Science. And then you get access to the actual original information about how new genetic information is added to an organism's genome. This took me about 5 minutes or so, or less, I think. So if you are really interested in knowing how new genetic information can be added to an organism's genome, then you would have done something like this a long time ago, and you would have known that there are several different ways this can happen. So my conclusion from that is that you don't know, you don't want to know. You want to be able to say, well, there is no mechanism because I have never been told. No, but you could have worked it out yourself as easy as snapping your fingers in a few minutes. Well, what do we have? 1, 2, 3, 4, 5.
Okay, sounds great. Thank you. Stefan, before we go on to new topics, give me a chance to respond to your 5 that you just did before we go into a new topic. Can you put your first one back up on screen? I'll let people see that and I'll give my response.
This one?
The first one, start at the beginning.
Yeah. Yeah, well,
okay.
Yeah, that's just an overview. The first example is this one.
Okay, the birds, there we go. Well, this is, of course, a drawing indicating something that could possibly happen. This is not observed to happen. This is just something, you're giving a theoretical way that it could be done. You're not showing that it ever has been done. You're giving a theoretical model of what could happen. And I would say real science deals with things we can observe, study, test, and demonstrate. And you mentioned this will only happen in a small population. Let's say there are, pick a number, 10 million cows in the world. Probably way more than that. But if we have 10 million cows and you want to slowly get some new genetic information or a mutation that's going to take over the cow population, even if it takes over a small area, which I think has probably happened with the different varieties of cows that we have. There are quite a few varieties of cows in the world. Or maybe take something more known to mankind, like maybe dogs, okay? If we had a naturally occurring mutation that would cause a dog to be larger, heading toward a Saint Bernard, which is obviously larger than a wolf, you have to not only get two of the opposite sex in the same place at the same time, what if one evolved 5 years before the other one, or 50 miles away? I mean, you're giving a theoretical possibility, and I appreciate all your work on this, but this isn't actual science. This is theory. This has not been observed to happen, which is why I say it's a religious belief. Maybe you don't like the word religion. I'll just use the word belief. You believe that this could happen. You realize, Stefan, this would have to happen trillions of times to change an amoeba to a whale and a hamster and everything in between. Trillions and quadrillions of times this would have to happen. And you're giving a theoretical example of how it might have happened. You don't really have science to back you up on this one. You have given a theoretical, well, it could work. And you may be correct. I was, okay, it may be correct. A cow could learn to jump over the moon. But so far it hasn't happened and nobody's observed it and we don't have a mechanism. So I appreciate your time on the drawings here, but I wish you could understand that this is a belief that you have rather than hard empirical science. And as long as you have this belief, that's wonderful. At least in my country, you can have any belief you want, theoretically. But to force this on all of the kids in the public school at taxpayer expense, where everybody is being forced via the public school system, everybody is being forced to pay for this belief to be taught. And I think most people that understand the topic are sick and tired of that. They say, look, you can believe anything you want. But what you have showed us is a hypothetical case. It is not observed. It's not been observed to happen. But thank you for the drawing. Go to your next slide, if you would. According to you, debate with R and Ra, if you call that a debate, I was promised equal time. He interrupted me 288 times. Yeah. I've since offered many times to continue the discussion with a few modifications. Aaron Ra will offer his best or his three best evidences for evolution in writing, or I can make a speech. I will then take his speech and be able to hit pause and insert my comments like I'm doing here. You gave your speech uninterrupted. I'm now going to insert my comments into what you said. I will still do that with Aaron Ra. I will not debate him publicly. He doesn't want to debate. He's a bully. And I will debate if his microphone is shut off when I speak, then yes, I might do that. But I said it's very simple. Aaron, you make your speech on the three best evidences for evolution. I will then interject, hit pause and interject, and edit the video. I won't delete anything. You then can take my combination of your and my speech and do it a third time where you get to interject on things that I say, and then I get to do it a fourth time. So we each get 2 rounds, and that's my offer still on the table. I will do that today if he's willing. I'll do that with anybody. So I'm not afraid of Aaron Ra. I'm afraid he can't follow the rules. It was supposed to be equal time. He got 62 minutes, and I got 36. Somebody counted that. I don't know if that's true, but that's what they said. And he interrupted 288 times. And when I mentioned that, they said, well, he had to interrupt because you were teaching things that weren't true. Well, then should I interrupt every time everybody speaks? I didn't interrupt you. So I'm not going to have a debate. So it wasn't a debate with Aaron Ra. He specifically said he did not want a debate. He wanted a discussion. So you need to fix your slide here. According to my discussion with Aaron Ra in March, I said a set of beliefs for a religion. A set of beliefs concerning the cause, nature, and purpose of the universe. Biological evolution does not talk about cause or purpose of the universe. I understand. There's more to the word. This is why we have to define, Stefan, what we mean by this word evolution. I slice it up into 6 different parts so we can look at each part carefully. Organic evolution, the or time, space, matter, where did that come from? If you've seen my slides on that, macro, micro, etc. You want to limit it down to what everybody, I think, would call microevolution, variations within the kind, and how do they occur? How do they take over a population? And I can understand your reluctance to include more than that, because any more than that is quite obviously religion. If we want to go down to what is called microevolution, my term and most people use that term, variations within the same obvious kind of animal, then yes, that would not include the cause, nature, and purpose of the universe. If that's your definition of evolution, then you are correct. It would not be correct to call it a religion. However, if you want to say that these variations that we observe between dogs, as an example, we now have 339 recognized breeds of dogs, nearly all of them created by man, nearly all of them would not survive in nature. You take the Chihuahuas and the Great Danes and turn them loose, they would both die in the woods. They can't fend for themselves. So I don't know of any beneficial things that have been done, even by man, with selective breeding to create a breed that's more hardy in nature. So there's a difference between natural selection and artificial selection. Under artificial selection, where man can protect it and select the smallest dog or the largest dog or the curly hair or straight hair, whatever they want to get. Yes, we can select and create and select out of an existing gene code very unusual traits. But it is a pure religious belief to believe that that process is going to improve it to something other than a dog. It's still a dog in every case. There are simply no exceptions. Or in your case of your bacteria colonizing, it is still a colony. It is still a bacteria. They did not evolve or develop the ability to kill their enemies with a machine gun or a hand grenade or an atomic bomb or a knife. It's only a matter of they get too large to be eaten. They're still identical bacteria. There wasn't new information added. They were able to colonize, collect together, and work together. I suppose a bunch of individual people out in the jungle would very soon learn to live together and work together and build houses together and farm together and develop a civilization of some type. That would be natural. But the individual people are still individual people. They didn't grow wings and fly. They didn't get an extra set of arms. And these bacteria that learn to colonize are still individual bacteria. That's not evolution. I wish I could get you to see that. So you said, I have the following options, except that the theory of evolution is not a religion, okay? I will say, Stefan, if you're going to limit it to your definition of variations within the same kind, then yes, you are correct. However, if you would see that this is a small slice of a much bigger definition of the word, and the word evolution is used in your school system and my school system. It is used all over the world as meaning the whole theory. I can show you, I've never seen a textbook from your country in my life. You send me one of your textbooks into English if you could, and I will show you where they do teach the Big Bang. They do teach cosmic evolution, chemical evolution, stellar evolution, macroevolution, organic evolution, life coming from non-living material. That is in your textbooks, and it is being taught at taxpayer expense. It is in your universities, and I've never been to your country, but I can come to you, take me to your science centers and universities. I will show you where they have displays of much more than what you're trying to limit the definition of evolution to. So by you wanting to limit it down to simply biological evolution, you may have a point that the word religion may not apply, but even biological evolution has two flavors. It has two stages: micro, variations within the obvious same kind, and macro, where it changes to a new kind. Your bacteria learning to colonize and work together is not going to change the bacteria to an elephant or a whale over trillions or quadrillions of years. It's not, you can believe it happens, and I think you probably do believe it happens. That's why it is a religious belief, Stefan. This is part of your religion. You believe these little variations can accumulate over enough time into something bigger. Wonderful, you can believe whatever you'd like. That's not science, and I wish you could see it. Then you said, I have an option of accepting that it's not a religion, but again, I would point out, my answer would be, that depends what you mean by the word evolution. Secondly, you said, I can suggest another generally accepted definition of religion. How about let's instead accept a different definition of evolution? Because if all six of them together, cosmic evolution, the Big Bang is certainly part of a religion. You have to believe that happened. Nobody's ever seen a Big Bang produce any orderly universe. Origin of life, life coming from non-living material. We call that organic evolution. Yes, that is a religious belief, Stefan. You have to believe that that happened somewhere, somehow, in a warm little pond. Or it came from outer space, which is silly, just postpones the problem, and creates many more problems. So how would it survive the transit through space? So no, I will not say that, I will continue to say evolution is a religion because I mean something different. But when I use the word evolution, I mean all six levels. So that's why, yes, evolution is a religion. Go to the next slide, if you would. Hitler claimed he was a Christian. This was a complete cover story. Hitler was no more Christian than my dog. You have to define what you mean by the word Christian. Hitler had a Catholic upbringing, somewhat, and he did, the Catholic Church helped him come to power with the sealed train that went across Germany with the gold on it and stuff to finance his armies. That's another long conspiracy story you can look up if you'd like. But Hitler, this is the same God with us. You better define what you mean by those terms. Which God are we talking about? Certainly not the God of the Bible. He did tell his soldiers that God was on our side, and it was our duty to eliminate these inferiors because we have to get the superior race. I think with 2 minutes of searching on the internet, Stefan, you could find hundreds of quotes by Hitler or his generals saying that the Germans are the superior race. How can you have a superior race, a blonde-haired, blue-eyed? How can any race, there's only one race, the human race, but in their thinking, oh no, there are many races. There was the black race, the Norwegian race, the German race. They divided each nationality up as similar to a race. So yes, Hitler did use evolution as his reason for justifying killing off the inferior, exactly like a farmer would do. If a farmer is raising tomatoes and he has an inferior tomato begin growing in his garden, something that is weak or sickly, he will yank it out by the roots because he wants to preserve his garden and make it strong and healthy. That's normal in any field of farming, whether it's you're raising cows and you see a sickly one or a diseased one, you shoot it, you get it out of the herd right away before it spreads. This is exactly the mentality that Hitler used, only on a worldwide scale. He told his people, we are the superior humans. And we have to eliminate the non-superiors, which would be blacks and Jews. You tell me, Stefan, why did he kill the Jews? What was the hatred there? Why did he hate black people so much? I think with 2 minutes searching on the internet, you will see that Hitler was a racist. He thought the Germans were the superior race. Now, whether he thought he was doing God a favor or not doesn't matter. The fact is, Hitler did use evolution as his reason for doing what he did. Evolution is a dangerous philosophy. It teaches that some are superior to others because of something they have in their genetic code. Just like your story with the birds, or your picture with the birds. If a bird had a red dot, oh, he must be superior. The other ones die off. Gradually, 2 red dots can get together, and they now have a superior improved gene. That's exactly the thinking of Adolf Hitler. Oh, we just happen to have the Norwegians with blonde-haired and blue-eyed, which I have, by the way. Blonde-haired, blue-eyed, and I'm Norwegian. So therefore, the superior race. So no, I will not change. I'm saying exactly the truth, and you know it, and everybody knows it that hears me. Hitler was motivated by evolution. Now, whether he claimed he was a Christian or not doesn't matter. He may have thought he was doing God a service. The Bible says in the last days, there are going to come people who will kill you thinking they're doing God a service. The Muslims think they're serving their God when they kill non-Muslims. There are 109 times in the Quran where Muslims are commanded to kill anybody who won't convert. The Muslims, Hitler only killed 6 million. Stalin probably killed about, Pol Pot, and the communism has probably killed about 60 to 80 million people. It's a rough estimate. Muslims have killed about 600 million in their history since the year 600 when they started. Muslims kill people who won't convert because they're doing it in the name of God, their God, which is not mine. But in the name of their God, they kill people who won't convert, and they think they're helping humanity. And their idea is the world will be perfect when everybody follows their God and everybody else is dead. Hitler thought the world will be perfect when we wipe out all these inferior races, and he's killed a whole bunch of people trying to do that. So no, Hitler does tie in very clearly with the evolution theory and the dangers of how it is when we teach people that any animal is superior to any other animal. Now, every farmer will eliminate the sickly in his herd or in his garden, or if you found a mold growing in your yard, you probably would dig it out and burn it to prevent it from spreading in the yard. Hitler did what he did because of evolution. So having God involved is a red herring to draw people off the point. Hitler could have believed in, I don't care, didn't matter what religion he kept, and he was very loosely a Catholic. But there are many quotes, and in 5-minute search on the internet, you can find lots of times where Hitler was using Christianity as a cover for his actions. Okay, next slide, please. Okay, I mentioned this already. Your bacteria colonize, combining for a common defense. No different than a bunch of people when they get attacked, they all get together and say, oh, they're attacking us, let's build a fort, and let's have a colony of people together. They are still individual people. Nothing changes in the genetic code that is going to change them into anything else. They're still a bacteria. And if you believe this example you're giving of these bacteria learning to colonize and work together is going to turn them into a whale or a giraffe or a human, you are illustrating clearly that you have a religious belief. This is not science, Stefan. I wish you could see it. It's not science. Is there one more slide after that? Yes, okay. You said that I've debated, Hovind in our last debate, I've debated scientists, but no one's ever shown me a mechanism that can add new genetic information in an organism. I did not see the video clip you have here, but I have searched the internet and read many of these papers that talk about new genetic. Read them carefully. They're saying this could happen, this might happen. It's not observed to happen and take over a population. This, again, is a belief. They may give an example like your colony of bacteria getting together to form a colony. I'm sure there are thousands of examples. I bet if we threw squirrels into the river, they would soon learn to swim. Okay, there's still a squirrel and it's still a bacteria. There are no examples that I'm aware of that you've shown or anybody's ever shown where this really creates new information that is then passed on and takes over a population and improves it somehow. Stefan, to change from a bacteria to a whale would involve trillions and trillions of these happening. To give a few examples where it happens on a very minor scale, where they can handle better temperature, higher temperature or lower temperature, or whatever most of these papers are about, and most of them are about microscopic creatures like bacteria or amoeba, learning to handle a new environment where you spray some kind of pesticide and they become resistant to the pesticide or resistant to the antibiotic. And so is it new information? If a person is born with no feet, and now they cannot get athlete's foot. Oh, so athlete's foot spreads through the world and kills everybody that has feet, and the ones with no feet survive. That, in theory, could happen, but it's not new information that accumulated anything beneficial. Okay, that's my response to your leftover. You want to hit it again, you can, or go on to something new. Your turn.
Okay. I just put on a slide that says accumulation of genetic complexity. Do you have that?
I have your slides up. It's creation versus evolution.
Accumulation of genetic complexity, gene duplication, and function-changing mutations. Can you see that?
Oh, there you go. Now I see it. Okay. Yes, sir.
Okay. Okay. The blue arrow is pointing to 3 little yellow dots. Well, this is these 3 lines. These 3 lines are representing the genome of each of 3 different populations of E. coli, which has been grown for several generations. originally these 3 lines of E. coli was completely identical, and they had their chromosome sequenced. And then later, after several thousand generations, their chromosomes were sequenced once more. And what the investigators saw was that except for a lot of point mutations and some rearrangements, there was also some gene duplication events, and which is that a part of the DNA is duplicated so that it now is present in 2 identical copies. Now, strictly speaking, that is not new information because it's just 2 copies of the same information, but it is an additional an addition of the amount of DNA in the genome. The red dot or the red square to the left is actually also a somewhat larger duplication. So these duplication events causes the genome of these bacteria to grow just ever so slightly, but when it takes place over and over and over again, then the genome can grow fairly much. Now, that's the first step. That's the duplication, but that doesn't add any new information. It just adds new DNA. What we have to show is that this new DNA actually also turns into new information, and I'm going to show that just in a second. That was just to comment on the last one. I'm not going to comment any further on the 4 other topics. I will leave that to our audience to evaluate, to decide for themselves whether you answered my questions or whether you didn't. And I refer to our debate in September, where I actually answered some of the questions that you posed. But for now, I just go on and say, well, we'll leave that and see what can we say about the adding of new genetic information to organisms' genome. First, we have to appreciate what is we actually looking for. We have the theory of evolution, and when I say evolution, I always mean biological evolution. I don't accept your 6 different parts of evolution. They are not part of the scientific way to use the word evolution. I have tested that. I've looked into the scientific literature through the Web of Science, which covers all scientific literature, and most of the ways that the 4 first ways you use the word evolution is never used in science. One of them, chemical evolution, is now and then used as you use it, but mostly it's used in a completely different ways. And the 3 others are never used in the way you use it in scientific literature. Never. You can test it yourself if you can. So what do we need to? What can we predict if we accept the theory of evolution, biological evolution, what you call micro and macro? Those words are sometimes used in science also, but mostly we just call it biological evolution or just evolution. What do we need to confirm this theory? Well, to confirm a theory, you have to make predictions, and those predictions should be precise enough so that you can see whether the observations you make are confirmation or rejection of the predictions. And that's the way science works. You cannot just say, well, we should look for this and that, if that is not what the theory says that we should expect to see. This dots doesn't produce non-dots, no, but the theory of evolution doesn't say that we should see that, so that's not an argument against evolution. We should work out predictions from the theory, and then we should go look for observations that can either confirm or reject those predictions. That's the way it works. So what is not needed? A direct observation of a suggested phenomenon, in this case, the evolution from one kind of animal to another, whatever kind means, is not necessarily part of the predictions. You can have phenomenon that is part of the theory, but that has a structure so that you cannot expect to observe them directly. I made a number of comments on that in our last debate in September. In evolution, what we should expect from evolution, but not necessarily be able to see, is, for instance, common descent. By definition, you cannot directly observe common descent, and the evolution of new kinds of animals is mostly supposed to be a too slow a process to be directly observed. But what we can see, what we should predict from evolution, and what we should expect to observe is, for instance, the following, and that is what I'm going to talk about. We should expect to see a clear pattern of successively larger genetic differences between anatomically more and more divergent species. I'm going to go into more details on that just in a second. We should also be able to identify mechanisms that result in new genetic material being added to the genome. That was what I was showing you with the bacteria just a second ago. We should be able to identify beneficial mutations, and we should be able to see variation in fitness among members of the same species, because if there's no variation in fitness, then natural selection has nothing to work on, and then you cannot expect anything to evolve. And you have to be keen on what fitness means. The way the term fitness is used in biology means reproductive success. It doesn't mean survival, not as such. Of course, survival is a request for reproduction. Fitness actually means reproductive success compared to the average reproductive success of the species in question. That's the definition of fitness in biology. Then we also should be able to identify new genetic and anatomical features on a small scale, not on the large scale, not like dogs producing non-dogs, but on a small scale in closely related species. And well, this dog producing non-dog, well, actually it's a straw man argument. I'm not going to go any further into that. Here we have an example of genetic differences between anatomically more and more divergent species. The red is what is identical, and the black is what is different. All the letters are referring to amino acids, and this is one of the smallest known genes in the entire biological system, I think, the ATPase gene, which is encoded by the mitochondrial DNA. It is somewhat different in length in different species, but mostly between 50 and 70 amino acids long. And I have found a number of examples of this gene in various species and compared them, and it follows exactly the pattern that you should expect. You have to appreciate that a lot of arguments in favor of evolution is actually not about individual observations, but about pattern of observations. And here it is not so much the level of identity between these genes that are interesting. It's the pattern of the level of identity, and that is what I have tried to illustrate. If we look within the wolf species, then the two most different individual sequences I have found is 91% identical, 9% different, 91% identical within the wolf species. Within the genus Canis, Canis lupus is a wolf, Canis dustus is a jackal. The most different two sequences I found was 86% identical. If you then compare to the domesticated cat, which is within the same order as the wolf, but a different family, the order Carnivora, carnivores, and then you find 72% identical. Going on to mammals, you find 39%, and and so on and so forth. And you could put in various sub levels here. You could put in the dog family between the genus and the order level. You could put in the dog family, and you would most certainly find intermediate level of identity. Between the carnivora and the mammalia, you could, for instance, put in the placental mammals, because I have used a placental and a marsupial, the wolf and the koala. But if you compare two placentals, you will most certainly get a level of identity that was somewhere between 72 and 39%, depending on which orders you compare. Now, you could say that, well, of course, the genetics reflects the level of differences between the level of differences in anatomy, because the anatomy is guided by the genetics. That would be a natural question to ask, but the thing is that the mitochondrial genes has nothing to do with anatomy or physiology. There are 13 protein coding genes in the mitochondrial genome, and all of them has to do with very, very basic biochemistry. They have to do with extracting chemical energy from various biomolecules. And exactly the same genes are present in all animals. Exactly the same 13 genes are present in all, or at least the vast majority of animals. There might be a few exceptions, but very few. And also the same genes, or at least most of them, and the same biological process, the same biochemical process is found in fungi, in plants, in various unicellular organisms, and even in bacteria. Some of the same genes, and certainly the same biochemical process is found. So this has absolutely nothing whatsoever to do with anatomy or physiology. So why would a creator decide that the domesticated cat should look more, or that the wolf should look more like the domesticated cat than it should look like a koala in a process that has absolutely nothing to do with being a wolf or a koala, but could be as well being about plants or fungi? I haven't heard any good explanation to that. I have heard attempts to explain it, but no one has suggested a good explanation to it. So I'm very keen to hear what you have to say about that. Just one example there, a little bit more, then I'll leave it to you. I shouldn't take all the time. Last time we talked about de novo genes from non-coding DNA. I will just round that off, or just end that little thing with just one little remark. Otherwise, I will really recommend people to watch our previous debate. I put the thing on the first slide. I think it was rather interesting. What I'm going to do with the rest of our time, which I'm afraid is not very much, is a little more about gene duplication and subsequent mutation. But just a second. Yes, here we are. I just end the story about the de novo genes, then I'll leave it to you to comment. When we talked about de novo genes, I described it as we had a start codon, and then we have a number of amino acid coding codons. But then there was a stop codon that stopped the process of constructing a gene, and therefore no functional protein was produced. And then the process of producing a gene where no other gene has been before is actually, at least sometimes, the mutation of the stop codon so that it turns into a protein coding codon. If people are not acquainted with the details of protein production, then they again should look at our previous debate, and there's a short description of that. But in short, when you change a stop codon to an amino acid coding codon, you get a much longer signal from start to stop, and that could, in some instances, result in a functional protein, and that is what has been shown to go on when de novo genes are constructed out of a piece of DNA where no gene was before. You suggested a linguistic analogy, which I actually think was quite good, that this stop codon could be like a full stop in a string of letters. And I've illustrated that at the bottom. We have INFOR, full stop, ATION. It doesn't mean anything, but if we change the full stop to an M, which corresponds to a point mutation, then we suddenly have information. If we have a stop codon in the middle of a long sequence of DNA, then we might not have anything meaningful, but if we change it to, by a point mutation, change it to an amino acid codon, then we might have a functional protein. And actually, in our latest debate in September, I showed quite a number of examples where this has been found in nature, proven to have taken place. But I shouldn't take more time, so please comment.
All right, well, thank you so much. If you can go back to your first slide again, I will comment on your slides. Made notes frantically. Yes, that was it right there. Okay, let me call it up for everybody to see. Okay. The gene duplication gives you more, basically, letters of the alphabet, and then you're hoping that after so many duplications, this is going to create new information. If we had a cow that produced a baby with 5 legs, it has additional information. It has the ability to make another leg. It's always harmful to the cow. In the nature, it would not survive. Mutants don't survive as a general rule. All known mutations are harmful, fatal, or neutral. I'd like somebody to show me a beneficial one. You've given a theoretical situation where you think, I'll use the word believe, because I do think it's a religion. You believe that this process changed a bacteria to a whale over 4.6 or 600 million years, or whatever the length of time it was in your thinking. You believe that this process is possible, could possibly change a bacteria to a whale. Oh, I'll give you trillions, quadrillions of years. I'm pointing out this isn't science. This is never observed. You've given a theoretical possibility that you think it might happen. Okay, great. I think if we train a cow really hard, work out with weights, we could get him to jump over the moon. Okay, I can believe that if I want, but it's not been observed. Go to your next one. Oh, you said you don't accept my 6 definitions of evolution. It's never used in science. Oh, well, I'm aware of that, Stefan, but it should be. Anytime you're going to use any word in a discussion, you should clearly define what you mean. Are you saying that microevolution is a part, if you just want to use one word, is observing dogs and wolves coming from a common ancestor, is that evidence for the Big Bang? Is the Big Bang a totally different field? Is it not part of evolution at all? Is the origin of life not part of evolution at all? Because you have to have life start somewhere. About a dog coming from a non-dog, well, I'll get to that when you get up to that in a minute. So you don't accept my 6 definitions of the word evolution. I'm wondering if you believe that what we observe with farmers producing different varieties of corn or cows or tomatoes or whatever you want to pick, any living form, we do observe incredible variations within the living forms. Is that therefore evidence that life came from non-life? Or is abiogenesis, i.e. I call organic evolution, is that not part of the theory at all? If it's not, then why don't you help me get that out of the textbooks? Because I can show you in your textbooks and in your science museums over there and science centers where they do teach organic evolution, life coming from non-life, abiogenesis. They do teach the Big Bang. So if that's really not part of science and you are really concerned about purity of science in your country, then get that stuff out. But if you think the varieties of cows are bacteria or bacteria learning to colonize, if that's enough evidence to help have you believe that bacteria are turned into whales over billions of years, then you must admit this isn't observable science. Go to your next slide, if you would. Let's see. Something about to confirm a theory. There we go. Right there, right there. Yep, right there. No, back up, up two more, but one more.
Oh, yeah.
Okay, there we go. Yeah, perfect. Okay. What is needed for a theory to be confirmed? Prediction should be precise enough to be confirmed or rejection. Okay, good. Stefan, I'll give you my theory. I have a theory that animals and plants will always produce offspring that are similar to the parents, and that there will never be any major changes into a totally different kind of creature. I predict no plant will ever produce an animal offspring in 1 trillion generations. I predict pine trees will always produce pine trees of some kind. Now, some may be taller, some may be shorter, some may have bigger pine cones or smaller pine cones, more seeds or less seeds, be able to handle cold winters or be able to handle hot summers. There may be variations within the pine, but I predict they will always, without exception, make pine trees. My theory, I think, has been confirmed. All observation from every farmer in the history of the world, every farmer will tell you his cows produce cows, his dogs produce dogs, and when he plants corn, corn grows. So I think my theory has been confirmed. Your theory that corn and dogs are related, if you go back far enough, is not confirmed. It is pure theoretical, but it's not. You should reject that theory. So you said, what is not needed? Direct observation or of the suggested phenomena need not be part. Okay. If you don't observe any animal ever produce a different kind of animal, but you still think it happened, that's been my point for years, Stefan. This is what you believe. You can believe it all you want. And of course, the magic formula is add more time. Time is always the secret ingredient to make it happen. What we don't observe over short periods of time, you believe, capital B, believe that it could happen with longer time. Common descent. Some predictions, I'm reading from your screen here, some predictions from evolution. We should expect a clear pattern of successively larger genetic differences between anatomically more and more divergent species. You're mixing the word species here in, this is kind of a nebulous term. A dog and a wolf are different species, but they're the same kind. I will stick with the biblical word kind. We do not see a pattern that's going to cause anything to change to any other kind of animal. This isn't observed. You said evolution would predict mechanisms that result in new genetic material being added to the genome. I don't believe you've shown that. Adding letters of the alphabet. I'll show you my example in just a minute about that. Or deleting letters of the alphabet, deleting part of the gene code. I don't think it's been demonstrated that it does produce something new. Beneficial mutations, I think you would agree, and I know most biologists will agree, that 99.99% of all mutations are harmful, fatal, or neutral. If you want to believe that the very, very tiny percentage of beneficial mutations is going to drive your process, I think you have incredible faith. I greatly admire your faith. I don't admire your science on this one. Your faith is incredible to think that 1 out of 1,000 beneficial mutations, if they exist, is going to change it over time to something other than its obviously recognizable kind, that a 5-year-old can tell you it's the same kind. Variation in fitness among members of the same species. This is, again, right back to Adolf Hitler. The blonde-haired, blue-eyed Norwegians are the most fit, and the German population eliminated the inferiors that were not fit. They executed the inferior. Look what they did. It wasn't just Jews. Anybody who objected to Nazism was eliminated. It was eliminate the unfit. He wanted fitness among his people. They had exercise programs for the kids. You better study what Adolf Hitler did to that country. New genetic and anatomical features on a small scale in closely related species. Again, you better define the terms. I think we do see anatomical features, for instance, bigger dogs or smaller dogs, but that's where it stops. It has never gone any farther. Okay, go to the next slide, if you would, please. You mentioned, I think I got the quote right, that dogs, that I always say dogs produce dogs, And you say that dogs producing non-dogs is not predicted by evolution. Well then, Stefan, do you believe there are dogs in the world? I think I can answer for you. Yes, you would say there are dogs. Okay. Do you believe they came from something long ago and far away, as long back as you want to go? Did they come from something that everybody would agree is a non-dog, like a bacteria? You believe bacteria slowly turned into dogs, do hundreds and thousands and millions of steps. But now, you're kind of confusing, muddying the water here. By saying a dog will not produce a non-dog, you're kind of implying, well, the dog kind is dead-ended. It made it to dog, and now we're not ever going to ever see a dog produce a non-dog. But if you wind the clock backwards, you do believe that dogs came from something that was non-dog. So instead of looking at it going forward, dogs producing non-dogs, let's go backwards. Did dogs come from a non-dog? And I think I can answer for you, yes, you believe they did. And then I would say, that's not science. It's a religious belief. You're breathing into the microphone, I think, there, Stefan. To confirm a theory, make precise predictions. Okay, no, that's from the previous slide. My notes are. I did make a precise prediction based on God's word. God said 10 times in the first chapter of Genesis, they will always bring forth after their kind. It's repeated 10 times in the flood story, Genesis chapter 6 and 7. They always bring forth after their kind. Plants do it, animals do it, bacteria do it. There are no exceptions. Straw man argument here. We should not expect to see a dog produce a non-dog. Again, I'm pointing out that you're looking at it going forward in time. If you go backward, this is exactly what you do believe. I wish you'd see yourself in the mirror and admit that. You do believe that. Go one more slide, if you would. Okay, you have lined up letters representing the CATG, the different parts of the genetic code, pointing out that little bitty changes indicate a different Canis lupus, and different from Canis domesticus, Canis adjustus, etc. I agree. There are differences in the genetic code, and somebody has lined up all these letters and pointed out that the within the species, they're 91% identical, and reading your second line, within the genus, they're 86% identical. I wrote down a sentence here, Stefan. I hope you'll understand this here. Here's my sentence, and don't take it for reality that I'm going to actually do this, okay? This is a sentence. I want you to know it has about 54 letters and spaces and commas and periods. Stefan, comma, next week I will give you $1 million, period. That's going to, quote and end quote. Just by a quick count, about 54 letters. So here's the sentence. Stefan, next week I will give you $1 million. Let me say that sentence again, changing one letter, less than 2% change. Stefan, next week I will give you $1 billion. I have changed one letter and have radically changed the meaning of the sentence by 1,000 times to go from $1 million to $1 billion. Let's try it again. Stefan, next week I will give you $1 trillion. Well, now I've changed one letter and introduced one more letter. One little tiny change in a sentence I made up in a few seconds is radically different, less than 2% change. So these little bitty changes that people like you like to line up on paper here and say, wow, look at how many similarities there are in the order of sequence. You have to understand changing one letter in a sentence can radically, completely change the meaning of the sentence. Let me do it one more time. Stefan, next week, I will not give you $1 billion. Now I've added 3 letters and completely reversed the meaning of the sentence. So the DNA code of each of the animals may have some similarities. You may be able to line up the DNA code of a tomato and an elephant and find certain lines of code that are very, very similar. You may find the pattern to be similar. Okay, that does not prove a common ancestor. That proves a common designer. The same guy wrote the code. I think I could line up the letters or the code for Microsoft PowerPoint and line it up right next to Microsoft Word and find tens of thousands, maybe even millions of identical lines of code. That's proof the same people are writing the code. This is not proof that they all evolved from Morse code or something else. So, Stefan, I wish you could see that. Lining up the letters of the DNA of different creatures, and therefore making a conclusion as far as how closely they are related, and therefore making a chart and a graph and drawing lines between it. That's nonsense. I could do that with letters of the alphabet if I had time and interest. I did that once years ago. I changed a cat to a cot to a dot to a dog by changing one letter at a time. There's a difference between a cat and a dog. A lot of differences. There's certainly a difference between a cat and a cot, which you sleep on, but it's only one letter difference. So these little one letter differences, you guys like to point out all the similarities, and you're missing the point completely that these similarities are evidence of a common designer. I'd like to introduce you to him, Stefan. God made the world in 6 days. That's the only way it works, with plants and animals requiring each other for many things: pollination, eating, reciprocating gases. And God that made the world died on the cross to pay for your sins. He wants you to become one of his children, and so do I. Now, he probably loves you more than I do. I've never met you, but I'll try. I suspect, though, that you are using your great intellect, and you certainly are a very intelligent man. I suspect that you're using that, though, to spread the teaching to other people, like your students. Maybe not so much in math class, I hope not. But you're teaching your students that you believe in evolution, and you may be harming some of your 17 to 19-year-old students in their quest to find the true God of the universe. Jesus said, if you offend one of these little ones, you're going to be better off with a millstone hanged about your neck. So I think I'd be the best friend you had if I told you you're on dangerous ground if you're teaching this to other people. You're teaching evolution. Even if you sincerely believe it, you shouldn't teach that, because it's going to destroy some child's faith. Read Matthew chapter 18 and see what Jesus said about that. I'm here to warn you. Watch our YouTube channel, Kent Hovind Official, where every night I go through some verses from the Bible on this topic. And on my website, drdino.com, there's a section in there, how to be saved, how to give your heart to the Lord and become one of his children. I'd love to see you do that. Okay, Stefan, we're out of time. Thank you so much. Are there any final comments you wanted to make?
Well, I would really like to comment a little on this slide we have here, because I am absolutely positively sure that you will agree that within the species wolf, the differences and identity is due to common descent. Within the genus Canis, the differences and identity is due to common descent. It is due to the wolf and the jackal within the genus Lupus the genus Canis having the same ancestor. So what you are saying is that there is some mysterious thing going on. First, we had identity referring to common ancestry. Next line, we have identity referring to common ancestry. Next line, we have identity suddenly not referring to common ancestry. That makes absolutely no sense, no whatsoever. And the ATPH gene has exactly the same function in all these species. It is not change of function. It is only change of sequence of amino acids. Now, you asked me to conclude. Do I have a conclusion thing? I think it's the number 40. Just a second. Concluding remarks. Well, you want to stop this. This is okay. I have tons of examples of new genetic information, beneficial mutations, and things like that. I showed you some of that in our latest debate in September, and you actually accepted that some of the examples were actually showing that new proteins were produced in some of these species. That is what you said in our debate in September, that you accepted that new genes could actually pop into existence out of absolutely nowhere. But apparently we can really never get to the bottom of this. So instead, if we are going to do another debate, I would love to show people how you misunderstand evolution.
Okay.
I have collected quite a number of examples where you will really have to explain why this is not a completely misunderstanding of evolution. I would love to have such a debate with you, but I don't know if you can read that. but that would be nice. In this and our previous debate, we have seen, well, I haven't gone through all that I wanted, so...
okay, we'll do another one. We can do another one, no problem.
Really correct to say that I have shown these things, but I will put the entire slideshow into my webpage. Just go back to the first here. This creation versus evolution, and if you follow biology and follow Hovind, then the slideshow will be there, and there will be a number of different examples where I show that beneficial mutations do occur, and accumulation of genetic information do accumulate in the various organisms.
Okay.
So that's more or less it. My contact address is there, and the link to the previous debates is there, and my webpage. Yeah.
Okay, for those that may only get this on audio, let me read this. The contact is STFR for Stephen Frello, STFR@hotmail.com.
Yeah.
And they can get anything you'd like there. Okay. Well, thank you so much, Stefan, for doing this. It's been, what, 3 times now? It'll probably take about 3 more to get you converted, but I'm persistent. I would like to point out one thing, since you gave rebuttal a little bit about the lines of code. I think we could point out that Microsoft Word and Microsoft PowerPoint have a lot of similarities. They probably go to the identical spell check dictionary. I think if I'm in PowerPoint and click spell check, it'll take me to the exact dictionary that it does when I'm typing in Microsoft Word. However, if I was using an Apple computer, written with completely different people involved and completely different, sometimes I don't know how that Apple works compared to Microsoft, but just as an example, I think we'd find there'd be many, many differences. Much less similarity because different people are writing those code lines. So I think what you've clearly demonstrated is that the lines of code of the mushroom and the dog are, what, 17% similar, or whatever the number was. Yes, mushrooms and dogs are different. So they have different functions. So the code lines indicate what it has to do. There are probably no lines of code in a mushroom to tell it how to build a leg. But there are thousands of, probably millions of lines of code in a dog to tell it how to build a leg. Mushrooms don't have legs, but that wouldn't mean the same designer didn't write the code. So anyway, let me ask you this question, Stefan. You don't have to answer if you don't want. You teach in a public school over there in your country. If you did, stop believing in evolution. If you did, become a young earth creationist like me, I know that's anathema to you, okay? But if you did, someday wake up and say, you know, there's a creator, and he wrote a book, and I'm going to believe it, and I'm going to be a young earth creationist, and I'm going to, when I teach my students on a topic where I can slip it in, I'm going to teach them creation and teach them the Bible is true. If that happened to you or someone else in your school system, would you lose your job?
Well, if I slip in biology in my math class, I think I would lose my job, whatever I taught them. I'm going to teach math in my math class. I'm not teaching biology. If I was to teach biology, I would have to stick to the curriculum.
But there are many biology teachers here in America who do not believe the curriculum, but they teach it. And then they tell the students, here's what the book says, here's what you have to learn for the test, but I don't believe it's true, and here's why. If that happened in your country, would that teacher be fired? Is the curriculum God? Do you ever depart from the curriculum in your math class? I taught math and science 15 years.
There are I have some options to add whatever I think is appropriate, but of course within the topic of mathematics. Actually, we have a university teacher who actually is very keen on Michael Behe, you know, the guy that wrote Darwin's Black Box and intelligent design movement. One of the first to note intelligent design in the modern version. Well, intelligent design is more or less just creation in other clothes, but nevertheless, this modern version of creationism called intelligent design. Michael Behe started that movement, I think, 20 years ago or so.
Right. Yeah.
Writing this book, Darwin's Black Box, and there is, I happen to know, I have talked to him, a person in the University of Copenhagen who is very, very fond of that. I don't know if he uses it in his teaching. I would think that he do not. It would not be looked at with nice eyes, but at least he is there. And as far as I know, Michael Behe still has his job at the university where he has been for several decades. So not everybody is fired just because they don't stick to the evolutionary theory.
Well, Michael Behe would have tenure. They would have a difficult time firing him. Yeah. There have been hundreds, maybe even thousands of teachers who did not have tenure, who tried to teach something other than evolution, i.e., creation, and were fired. Have you seen the movie?
Well, actually, I think that's fair, because creation is not science.
So let me make sure I got your quote here. You think it is fair to fire a teacher who believes in creation if they teach in a public school?
Not for believing it, but for teaching something that is not science. In the science.
But if a teacher in science class teaches something that is not science, it is fair to fire them. Is that your position?
You haven't, Mr. Hovind, you have not shown that evolution is a religion. I have to point out that to our audience, that you have not shown it. You have constantly said it, but you have not shown it. You have not shown that there is a definition of religion according to which biological evolution is a religion. You have not shown that.
Are there any teachings in your biology classes that cannot be supported by science, like observing a bacteria turn to anything other than a bacteria? But you have textbooks that show bacteria turned into whales.
Well, as I have
is that science? Is it science to say bacteria turned into whales over billions of years? Is that real science?
Well, as I have said several times, you don't need to have a direct observation of something that is a consequence of a scientific theory. If you can show that the predictions, a number of predictions that scientific theory comes up with, then you can argue that it is actually a scientific theory and that it should be taught. Just like 100 years ago or more, the theory that that matter was built of atoms was very, very far from being the result of a direct observation. It took several decades before anyone was anywhere near to directly observe an atom. But they had so many good indirect observations and theoretical considerations that showed that atoms must exist, and therefore it was solid science that they existed.
I have some very good indirect observations that God exists. I talk to him many times a day. He changed my life radically. I've seen him change millions of people down through my lifetime, and through history there are probably billions of examples where God exists. So I have some very strong indirect observations. Plus, well, we'll talk about that next time. Thank you so much for doing this. We're way over time here. We'll do another one. You call Rhonda and schedule it. When you're ready, let me know. Okay?
Bye.
Thank you so much. All right. Bye-bye.
Thank you.
All right, folks, if you want to get a hold of our ministry, drdino.com, come visit us in Lenox, Alabama. You can call me, 855-BIG-DINO. It's 244-3466, extension 3, and I'll answer the phone if I can. Thanks, brother. See you later. Bye.
Okay. Hello, Ken Hovind here in Lenox, Alabama, Dinosaur Adventureland. It is December the 13th, 2018. I'm live on the phone with Stefan Frello, and who believes in evolution, and he thinks I do not understand evolution. So tonight's program, we're going to talk about what is the theory of evolution, and the questions that I have, Stefan, from you are, does Kent Hovind really understand evolution and what the theory says? So you wanted to start off. Let's let you go. I'll call up your slides and. Yeah, Stefan, tell them who you are, what you do for a living, what your education is, so they know who I'm talking to. Great, go ahead.
Okay, my name, as it says, is Stefan Frello. I'm a teacher at math for 16 to 18-year-old young people who are just about to attend university. I have a master in molecular biology and a PhD in botany, and that is my background. I have debated Hovind for a couple of times already, and I put in the links for our three previous debates, so people can find it if they're interested. And tonight's debate will be on the question we agreed on: does Kent Hovind understand the theory of evolution? And just to make sure that everybody knows what we are talking about, I will start by presenting very shortly what the theory of evolution actually says. It is a theory about descent with inherited modification through natural selection as the most important mechanism, working on random mutations. There are a number of premises for this. First, organisms produce more offspring than will survive. And second, the offspring is genetically variable. The third, some genetic variation influences survivability and reproducibility. And as the fourth premise, new genetic variation is supplied by mutations. And the conclusion based on these four premises is that the genetics of those with better reproducibility will grow in frequency over generations. And that is what inherent modification means. Of course, for this to be interesting, we have to assume, or that is what the theory of biological evolution assumes, that this natural selection will result in accumulation of complexity. And that, of course, is only possible if new genetic variation is supplied all the time, and if some of this new generation is actually beneficial for the organism. But that is the theory that we are working on. The format of our debate, just to clarify, it's not a debate of whether evolution has been proved true or not. It's entirely about what the theory of evolution actually says and whether Kent Hovind understands it, or rather Kent Hovind's understanding of it. We agreed on a format where I'll make a short presentation of an example that I think is a misunderstanding on your side, and then we will have a short discussion about that. And when we think that we have exhausted the arguments, we can go on to the next example. We'll try to keep it one topic at a time so we don't confuse our viewers. Most of my examples are taken from the two videos that I present here. Each of them is about 1.5 hours and can be found on YouTube. Could I go on to the first example, or do you have any comments?
No, go ahead.
Yeah, okay. The first is about how is phylogenetic reconstruction actually made. Phylogenetics is the way various organisms are related to one another. We both agree that at least some species are related to one another. For instance, all the species in the horse family, we agree that those species are related to one another, and at least some of the species in the cat family, some of the species in the dog family, and so on and so forth, are related to one another. The question is rather, how far does this go? According to evolution, this goes as far as it gets. Everything, every single organism in the entire living world is connected by inheritance. Of course, if you take a plant and an animal, you have to go very, very far back in time to find the common ancestor, but eventually it will be there. According to creationism, at least as I understand it, you must correct me if I'm wrong, but according to creationism, we have separate created kinds, and each of those kinds have then or at least some of them, has resulted in some variation in some different species, but still very, very limited variation, as for instance, the different species in the horse family. But here is your presentation of what the theory of evolution says about phylogenetics. You have these two slides in your presentation, and then it comes. Penicillin only got 2 chromosomes, so they must have evolved first. And a little later, maybe we will have enough chromosomes to be a fern. But this is simply complete nonsense, because chromosome numbers has never ever been used by biologists in phylogenetic reconstructions. So there is nothing in the chromosome number as such that tells you about who have evolved into whom. And there are very good reasons for that. I do go on. Several other examples. Body weight, age, top speed, gestation period, I think it's pronounced. And all of these you use as if evolutionary biology use, or as if biologists use this kind of information for building phylogenies, for reconstructing which species are connected to which. And then you say they just make up these charts to say how we evolved. But no, they don't. You made up these charts. And none of these suggestions has ever been used by biologists. It's simply just stupid ideas. Because single one-dimensional measurements like these are never used in phylogenetics. It's a bit more complicated than that. So, on to your comments.
Yes, thank you, sir.
In criticizing evolution, I think you would know that phylogenetic reconstruction, how it is done, and it's not done the way you suggested. So please tell us instead of this strawman nonsense, how do you think that scientists actually make phylogenetic reconstructions? Or perhaps you should just admit that you don't know.
All right, my turn?
Yeah.
Okay, Steve, I click on me. Yep. There. Okay, thank you, sir. If, Stefan, let me ask you this. If the charts that I made, which were obviously done as a joke, as a humorous example of how evolution doesn't work in those cases, suppose the chromosome number did match what you guys expected. Suppose amoebas were a single chromosome or 2 chromosomes, and humans were the most. If the chromosome number did match and fit your theory, would you use that as evidence for evolution?
No, because,
you would not.
Because there are so many different. Well, I can show you examples of very closely related animals that have widely different chromosome numbers. Chromosomes fuse. Whole genomes, at least, well, not so often in animals, but often in plants, whole genomes are duplicated, so that we have one generation of a plant that has perhaps 24 chromosomes, and then the next generation has a double number. And in animals, that is thought to have happened a few times, but much more often chromosomes actually fuse and result in a reduction in chromosome number from one generation to the next. And that has happened quite often, and I can show you some examples if you're interested.
Well,
therefore, the chromosome number as such doesn't tell you anything about the complexity of the organism.
Would, instead of chromosome number, if it was the total genetic material, because some chromosomes contain more genes than others, I understand. Suppose we went through all the animals and plants in the world and added up how many genes they have. Obviously, you know full well that also would not match the evolutionary expectation.
No, it wouldn't. It wouldn't, because
genes are very complex.
Genes are lost and genes are gained, and this happens all the time. So it very much depends on whether you gain more genes than you lose, how many genes you have, and of course you have to have quite a lot of genes to form an animal, because an animal is, and even the simplest animals are very complex. So of course you have to have very many genes to form an animal, but exactly how many genes doesn't tell you very much about how complex the animal is, because genes are lost and genes are gained.
Would you agree that with computer codes, the more complex codes would have more lines of code, the more complex programs? Like, does Microsoft PowerPoint probably have more lines of code than, what's a simple program, Steve, some of the early ones?
Calculator.
Calculator. Okay, a calculator on your computer would have less lines of code than, say, a complex program. In this case, it's quite obvious, as well as being intuitive, that the number of lines of code does indicate more complexity. Why wouldn't it, with the more lines of code, which is the genes, why don't the animals and plants follow the expected pattern of more complex is more lines of code? You know it's not that way. Why isn't it?
Well, that is actually, I think that's more or less what is called the C complex question, that the amount of DNA or the amount of genes doesn't exactly match the complexity of the organism. But the problem is, or the answer probably is that the amount of DNA, or the DNA content of an organism behaves in some way independent of the organism as such. There are mechanisms in the DNA that can result in duplication of the larger or smaller parts of the genome, so that you can build up quite a large amount of genetic material without adding any complexity to the organism. So therefore there is no direct connection, and also a very, very large amount of the, as you probably know, the actual genes, the protein coding part of the DNA is only a small fraction. It's only a few percent at most of the entire genome. Most of the genome doesn't form protein coding genes, and a large part of the genome is actually just repetitive sequences that just goes on thousands and thousands of copies of the same short DNA sequence, which probably has no function whatsoever. So,
Stefan, you have a PhD in botany. You know full well some of those, they're constantly finding that those things do have uses. There's no such thing as useless genes that have been proven to be useless. They just didn't know the function of them. It's like back in 1925, they had 180 vestigial organs they said the body doesn't need. And now they found a use for every single one of them. So the fact that somebody says there are extra genes that don't seem to do anything, some of it's simply redundancy for in case of one breaks. But call up your first slide, if you would, please, and let me show you what you said you believe. Call up your first slide and I'll show the people.
This one?
Yes, sir, that's it. Organisms produce more offspring than will survive. That's generally true. The organism is genetically variable. I agree. Some genetic variations influence survivability. I agree. New genetic variation is supplied by mutations. I disagree, of course, but are you saying that when you get different genes, you are more likely to survive? So those with more genetic code would indeed be more complex, but they don't follow the expected pattern based on your evolution theory. You guys believe that genetic variety is how it has to happen. To go from an amoeba to a whale, there has to be a whole lot of new genetic information added. Whales are not amoebas, and amoebas are not whales. Something changed in your theory. Somewhere along the line, a whole lot of information had to be added to change from an amoeba to a whale. So when I make my charts, which are obviously done in jest to show the stupidity of the evolution theory, saying the number of chromosomes, or we could have done the same with the number of lines of gene code, or the number of offspring they produce. Why aren't the more complex animals producing the most offspring? Why do mosquitoes produce so many more offspring than humans. And so I did that knowing full well it does not match your theory. I'm sorry, go ahead.
It was just that most of the the young mosquitoes were eaten by birds before they have a chance to reproduce. So the number of offspring, when you compare different animal species, are not that interesting. It's the number of offspring directly competing to each other within the same species that are interesting. Well, when you look at the evolutionary process, but I have an example from my PhD, because part of my PhD was done on garden plants called crocuses. I hope you know that, I guess. And it turned out that the genus Crocus is very interesting when it comes to its chromosomes, because
hold it. Before we get into that, let me finish answering your question.
Okay.
Your question was, do I understand? And you said I do not understand evolution because of my examples of chromosome number, weight, age, gestation period, how long they're pregnant, things like that. I lined up those various animals in the order that they do appear, like how much do they weigh? Obviously, a whale weighs more than an amoeba, and so I lined them up in the order that they by weight, just to show this doesn't follow the evolutionary pattern, that how long they live, how many offspring they have, the number of chromosomes, the number of genetic lines of genetic code. There are hundreds of ways to line animals up that do not match the evolution. I'm well aware that you guys you pick and choose the ones you want to match your theory, but hundreds of other ways you could arrange them don't match, and so you don't use them and say, well, that's not evidence. Well, then that's not right.
There's absolutely no reason why any of these suggestions should match what you think that the theory of evolution would say. There's no reason to think that animals during the evolution only should grow larger and larger. Why should they? Why couldn't it be beneficial to be smaller and smaller? Why should it always be better to have a long life than a short, very active life? Breeding within the first very short period and then using all your energy on bringing up your offspring. Why shouldn't that sometimes be better than living a very long time like whales do, and wait several years before you breed for the first time? It simply does not make sense to postulate that evolution should expect life expectancy only to go up and up and up. We don't expect that. There's no reason to expect it. There's no reason to expect chromosome numbers to go up and up. There's no reason to expect top speed to go up and up and up. Sometimes it's better to dig yourself into the ground and stay there.
All right, so you're completely missing the point. You're completely missing my point, I think, deliberately. You are correct that I made up these charts, okay? I made them up intentionally as a spoof on evolution to show that you guys are going to pick and choose. If the evidence seems to support your theory, you will want to spread it and teach it. If it does not support your theory, like my charts do not, then you would say, well, we would not expect it to. Well, this is common sense 101 for a person with a brain that would say, hold it. Yes, those that have evolved the farthest should have the most complexity. They should have the most lines of genetic code. They should have the most chromosomes. Why does a fern have 12 times more chromosomes than a human?
Because
some have 1,200 chromosomes. That's in every cell.
There is no such expectancy. And actually, what you said, the way you put it, actually is very telling, because you said the one that has evolved furthest. No, we all have evolved equally far. We have all organisms living today has exactly the same number of years of evolution behind them.
Would you agree?
Some has accumulated more complexity than others, but we have the same number of years behind us since the first
4.6 billion or whatever number you're using this today. Okay, would you agree that there are some animals that are still alive that appear to be unchanged from millions of years ago? Is the cockroach very similar to the cockroach of millions of years ago? Is the clam very similar?
Yeah.
Well, why didn't they evolve? What happened to them?
They probably have a construction that seemed to be very, very well functioning, and therefore they survived without much change. Actually, that has been a great debate in evolutionary theory, especially, I don't know if you have heard about Stephen Jay Gould, but he has this, he has worked a lot of how come that we see so much stability, and because stability is actually the most widespread thing in biology. Most species tend to stay very stable. So it seems that something has to happen in order for change to happen. The so-called, what should we say, the default is that nothing happens. The default is stabilizing, that most mutations are wiped out by selection, and most genetic change is not changing the anatomy or the complexity very much. But then, once in a while, something happens that speed up this process, and the complexity or change in the anatomy of the animals do take place. But the most of the time, most species stay more or less stable.
Okay, Stefan, hang on, my turn here.
Yeah.
Can't you see how the creationist would look at this exact same evidence and say, as you said, stability is widespread in biology. Almost all plants and animals are doing fine just like they are. There's no need to change. Why can't you see that a creationist would say, yes, they were all designed fine. There's no need to change. They were made fine. They were made complete and perfect at the beginning. The reason the cockroach hasn't changed in 200 million years is because there's no change necessary. Cockroaches are doing fine. To me, what you're giving is clear. It was created perfect.
I can easily understand that a lot of people believe in that, and that was the way biology was until about 150 years ago. Everybody was very confident with that. Species was stable, no change. It took a while before biologists realized that some species have gone extinct. That was a great topic in the beginning of the 18th or 19th century, whether extinction was actually possible, because everything was thought to be so stable. So I can easily understand that, and the evolutionists has no problem with stability. Of course, we see it all over the place. We have still sharks, we have still bacteria, we have still moss and other things that have been with us for a very, very long time. It's not a problem. The problem is how to explain the change, and that is what Darwin did 150 years ago. But back to my actual question, because do you actually know how phylogenetic reconstruction is made? Because
Yes.
Even within what you would call created kinds, if there has been speciation, then a phylogenetic reconstruction would be relevant. Even within the horse family, which you repeatedly have accepted as having a common ancestor, the horse and the donkey and the various zebra species must have had some kind of history of speciation behind them, and that history should be able to be reconstructed. So how do we do that? If we just keep it within the horse family, for instance.
Okay. Well, let me ask you a question. Do you believe that the horse came from a single-celled creature like a bacteria?
Yeah.
Are there still single-cell creatures like bacteria alive today?
No.
Why didn't they all turn into horses?
Why should they?
Well, you're the one who said there is a need
It's a very, very good idea.
stable, but there's a need for change once in a while. Something happens causing them to need to change. What made the bacteria change if bacteria are still alive?
Yeah, but there's no, some of them were in a situation where it was a very, very good idea to turn into something else than a bacteria. And actually, well, it's a complicated story, of course, but
I think it's a fairy tale.
The world is, I think you should look at this. You have to look at it in a population kind of thinking. Also, it's easier if we talk about animals evolving into other kinds of animals instead of bacteria, because that's kind of another story. But if you have, for instance, at some point you talk about three-toed animals, which are supposed to be the ancestors of horses, and then evolving into one-toed horses. And what you have to think about in these terms is that we have perhaps a widespread species of three-toed animals. One of the divided into separate populations, which has only limited contact with each other. And one of those populations lived under circumstances where a reduction from three toes to only one toe was beneficial, and that was the population that evolved into modern horses. All the other populations did not live under such circumstances, but lived under other circumstances, so they did not evolve into one-toed horses, but stayed with their three toes. So you have to appreciate that even a single species, a widespread species, live under very, very different circumstances, and some of those circumstances might trigger the evolution from one kind of animal into another kind of animal. But the rest of the species, the rest of the populations of the same species, do not actually evolve at the same time.
I understand completely that that's what you believe. Now, let me point out some things that I think should be obvious. Mm-hmm. Going from three toes to one toed is losing information, less genetic and material code required to make one toe as opposed to three toes. Number two, you're not explaining at all how it got three toes to begin with. Bacteria don't have any toes at all. And you said you believe horses came from something like a bacteria. Somewhere along the line, it had to go from a bacteria to an animal with three toes. And then, so it had to go up to three toes and then lose them back to one to get a horse. Do you understand how all of this looks like a fairy tale, a magic story? It just happened. You have to imagine long ago they faced a problem. There are still three-toed animals today.
Yeah.
And they're today. Why don't they all have horses?
If some of our audience is very, very interested in the evolutionary history of the vertebrates, which is what you tend to talk about, then they should look into the scientific literature, which has tons of information of fossils found that represent all kinds of different transitional forms between fish and amphibians, and between amphibians and reptiles and mammals, and back in time between fish and something that is more or less like what is now called a lancelet, which is a very primitive kind of not quite vertebrate animal. And yeah, there are so many different intermediate fossils found to illustrate this transition between different kinds of animals. But I actually want to keep getting back to my question: how is phylogenetic reconstruction done? How do we do it? If you have the horse family, for instance, and you want to know how is the different species of zebra related to the donkeys or related to the domesticated horse, how is that done.
You have to understand, all they can possibly find of these creatures is fossils, which would be the bones. They're not finding the lung structure or the circulatory system or the
Sometimes they do. Sometimes they actually do.
Okay, that would be extremely rare.
Very rarely. But sometimes they find, of course, not complete structures, but impressions of lungs and other soft tissues, so that you can actually make out at least some detail of how they look.
Well, you're starting off.
Yes, that's right.
You have some very obvious assumptions in your theory. You're assuming that animals change at all when all the evidence seems to be stasis. They seem to be horses always produce horses, cows always produce cows, bacteria still produce bacteria. So you're assuming there needs to be a change to something else. Secondly, you're assuming there's a mechanism that will make them change, and you think added mutations is now what you're saying is what's going to drive this. Well, all observed mutations are harmful, fatal, or neutral.
No.
Nobody's seen a beneficial mutation, and you would need trillions and trillions of beneficial mutations to turn from an amoeba to a horse. And you can't, I don't think you can demonstrate one beneficial mutation.
Well, I would ask people to watch one of our, I think it was in September that I went through the arguments that prove that beneficial mutations are all over the place.
Well, refresh my memory for the audience sake here. What is the best beneficial mutation that you know of?
In Drosophila, that is fruit flies, there is the most well-known fruit fly, or actually one of the most well-known animals at all, is called Drosophila melanogaster, and a lot of these flies has been sequenced. Their complete genome has been sequenced, and other species of Drosophila has been sequenced too. And these flies look so much the same that none of us could tell one species from the other. So I guess that you would accept that they had a common ancestor, and you would point out that common ancestor was a fly, and it was. But in Drosophila melanogaster, some populations has genes that are not found anywhere else in the living world. And it can be shown by very minute genetic investigation that the sequences that make up these genes actually are found in the other species also, but they are not producing any genes there. And if you look very closely to the sequence of these genes, or these of the protein coding gene in one of the populations of Drosophila melanogaster, and find the corresponding sequence in the other species and in the other populations of Drosophila melanogaster, then you can see that these genes are actually new genes. They are not lost in the other populations or in the other species. They have been mutated into existence. They were not there before, but now they are there. New functional protein coding genes with a function. And some of them even has been shown to be very important for the reproduction of these flies. So, and there are many of them, there are hundreds of them. So it turns out that the more detailed you look at the genetics of an animal, the more obvious it becomes that the new genes are popping up all the time. And some of them, not all of them, most of them are probably lost again very fast, but some of them are beneficial, and some of them even turns into being absolutely necessary for the animal. So yes, beneficial mutations have been shown to exist all over the place.
Okay, now maybe you can refresh my memory. I don't recall the details on this. What is the generation time of the Drosophila, the fruit fly? How old are they when they have their babies? How many generations do you get per year? Or
I don't know, 20 or something like that.
Okay, so
I know where you were leading this. Why haven't they turned into something else than a fly? They haven't. Great question. I don't know why they haven't turned into anything else than a fly. So what?
Okay.
So what? And
okay,
I still haven't got an answer to my question. How do we make phylogenetic reconstruction? For instance,
I'm answering your question. You start with the assumption, first of all, that it did happen.
Within the horse family, we agree that it did happen.
No, I don't agree at all. But you start with the assumption.
The horses are related to each other.
Evolution didn't happen.
Don't we agree that zebras and horses and donkeys are related?
Well, let's go back to the fruit fly here. Stay with one at a time. Do you believe that, let's say they get a new generation every 2 weeks? I think that would be reasonable. So you get about 25 generations per year. They've been in the laboratory inducing mutations, forcing them to have mutations by changing their environment. You said something happens to the environment to make them need to change, like, colder weather, warmer weather, lightning strikes or whatever, okay? Poisons introduced to the water supply, I don't know. I agree, things happen to the environment that make things have to respond, or some die off. So here they've been in the laboratory for many years, I'm going to guess nearly 100 years, getting about 25 generations per year. So let's say they've gone through 2,500 generations of these fruit flies. They have induced some mutations that you think are beneficial. Are any of those flies, any of the ones with beneficial mutations, more likely to survive in the wild? If you just turned them all loose out of the laboratory, can you name one beneficial mutation that helps it survive in the wild? Is it beneficial to the fly in the laboratory? I don't know, but I'd like to know, where's the scientific evidence, A, that this can happen in nature, and B, that it has happened in nature, and C, that this is going to change a fly into a horse or a whale or anything other than a fly. Stefan, all they've ever gotten are flies, and nearly all of them are dying, or let's say babysit them. They have flies with curled wings, flies with no eyes, flies with no wings. I cover that on my video number 4. All they get are mutated flies, and if you think it's got some beneficial gene someplace, well, yay. But it's got 10 million to 1 negative genes. So it's like saying if we take 1 step forward and we slide back 7 steps, eventually we'll get to the top of the hill. No, you'll never get to the top of the hill. If you take 1 step forward and slide back 7 steps, you're not ever going to get to the top of the hill, and you're never going to turn a bacteria to a whale with this process you're describing, where 1 out of 1,000,000 mutations is beneficial, if that's true. It's not going to get you to the top of the hill, Stefan. You're not going to turn a bacteria to a horse or a whale or anything else. I know you believe it. So you guys make up these family trees based upon A, the assumption that it did happen, and B, the assumption that mutations are going to make it happen. And I'm pointing out there is no scientific evidence that any number of mutations is going to do this. The flies did not gain anything that is not already in the fly category. Flies already have legs and wings. They didn't get feathers. The flies didn't get fins to swim in the water. They're still a fly. Where is the beneficial mutation that's going to change to add some new feature that isn't already in the fly population?
You are sidestepping the question. I am not going to respond to that. I have already explained to you that beneficial mutation has been found. They are found in wild populations. They are not these. This example I mentioned is not from laboratory strains. It's from wild populations. So I'm not going to go any further into that. And I will insist that you answer the question. How is phylogenetic reconstruction made within what you would accept to be a created kind? For instance, the horse family.
Okay. You told us already that organisms have more offspring than will survive. That is, I think, generally true. You told us that genetic variations will survive. Some have genes that allow them to be more adaptable. So the animals are arranged in an completely imaginary order, going from less complex to more complex, from a single-celled amoeba up to a whale. Every night on my YouTube, Kent Hovind Official, I show the chart that the evolutionists themselves make. It's in all the textbooks, showing a family tree from a single cell to multi-cell to plants They arrange them in order of how they would like them to happen. They are never found in that order, and they are never seen to change into anything else. All the evolutionists do is use imagination. It is SpongeBob 101, in my humble opinion. So yes, you are arranging animals, all of the evolutionists are, in an order of increasing complexity based upon, that's why I point out, why don't you use the number of genes? Why don't you use the number of chromosomes? Why don't you use the gestation period, or how fast they can run, or how much they weigh? Because those things don't fit your theory. So of course you're not going to use that.
Then what do we use?
That's a great question. You tell me.
No, it's not. It is an extraordinary simple question. You can use about half an hour using your Google, and you can come up with a number of scientific papers that tells you exactly how this is done. You've done that, Mr. Hovind. Have you enough interest in this question actually to work out how is phylogenetic reconstruction done? If you don't have done that, then admit that you don't know.
Show me what Google says about phylogenetic reconstruction. What is it that you are driving at? And I will show you the errors in their logic.
But I am asking you within what you would accept as created kind. If we take the horse family, you repeatedly use that as an example of a created kind. Okay? So in your fairy tale story, to use your own words, all living horses, zebras, and donkeys today descend from a single pair of horses on board Noah's Ark. Isn't that correct? That is what you believe?
The Bible says clearly 20 different times the animals will bring forth after their kind.
Could you please answer my question, Mr. Hovind? Isn't it true that according to your belief, all horses, zebras, and donkeys today, alive today, descend from a single pair of horses on board the Ark?
Probably so. There may have been 4 horses on the Ark, or 6 horses. I don't know how many kinds. Let's say there are 2. I would agree that 2 horses could produce the horses, the zebras, and the donkeys. Okay. I do not agree that 2 amoeba can produce whales and horses.
No, but that's not my question. My question is, if we then are interested in the actual history of speciation within the horse family, we assume that they started with 1 pair, a male and a female, because that's what the Bible says. 1 pair of horses on board the Ark, and then they spread all over the world or whatever, and they start to speciate. And some of them turned into zebras, and some of them turned into donkeys, and some of them turned into what is now the domesticated horse. But there has to be some kind of history. They have to be related to one another in some kind, in one way or the other. How do we reconstruct that history? Just within the horse family.
I think there are some horses that have more ribs than others. There's the shorter horse. I think it's Mongolia, if I recall. They have 1 less pair of ribs, or 2 less pairs of ribs. I think you could easily... Pardon me?
So what?
Well, since your PhD is in botany, maybe we should do something more in your field. But
no. Stay at the horse family, Mr. Hovind. Now answer my question. Do you know? Yes or no? Do you know how we could reconstruct the phylogenetic history of the horse family? Yes or no?
Reconstructing the history of any creature, of course, would require a lot of guesswork and a lot of imagination. It's like reconstructing the history based on a
simple way to do it. My whole point is that you don't know.
I think I do. I'm trying to
explain. You claim that you understand evolution, and you don't know the very, very basic thing. How is phylogenetic reconstruction done? It's a very, very simple question that can be answered with 1 single word.
Imagination. Okay, my word is imagination. That's how it's done.
No, it's not.
Okay. They imagine that the whale came from a bacteria.
I'm not talking about whales and bacteria. I'm talking about horses.
Okay. You imagine that a horse came from a bacteria over billions of years.
Hovind, stay at the topic. Don't.
I'm on topic.
No, you're not. I'm talking about
horse family. I'm showing the stupidity of the idea that you think a horse could come from a bacteria. I think two horses on Noah's Ark could produce the horses, the zebras, the quagga, the mules, crossbreeds, the shorter horses, the longer horses, the taller horses, the smaller horses. I think all the horses could easily be put into a family tree, a phylogeny, and say, yes, these are probably all related. You could do the same with dogs or apples or anything else. But you guys then take that and go wild with your imagination and think, aha, see, this proves horses came from bacteria. This is where you jump from the science to imagination, to a religion. You believe it, and I feel sorry for you for having been taught such a thing, and you actually had to pay to be taught that stuff. So, yes, you do believe horses came from bacteria.
Mr. Hovind, you are so much stressing my whole point. You don't know. You simply don't know how.
Stefan, I told you, I do know clearly. It is imagination.
So
that's how you guys do it. You imagine that a horse.
So if we want to reconstruct the phylogenetic history of the horse family, just the horse family, we agree that all horses come from a common ancestor. And now we just want to reconstruct the phylogenetic reconstruction, the history of the horse family. No whales, no bacteria, just horses. Do you know how this could be done?
I think they would look at the variety of horses from a variety of sides. Let's look at the circulatory system. Let's look at the respiratory system. Let's look at the reproductive system. Let's look at
all that would be exactly the same.
All those would be very similar between a horse and a zebra. The integumentary system, obviously a little different. Zebras have stripes, not many horses do. I think you could look at the number of chromosomes and say, wow, they're pretty similar. You could look at horses and mules have eyes on the outside of their head instead of straight forward. A binocular vision, they have, I forget, peripheral vision, I forget the name for that one. Their eyes are on the side of their head. I think we could arrange animals like that and come to some conclusions that, wow, these are the same kind of animal. The horse, the zebra, the short horse, the Mongolian horse, the Shetland pony, the Clydesdale could have easily had a common ancestor. And that's where that is correct. We could do that with buildings or with tools, you know, in the shop, or there's all kinds of ways to create a phylogeny, a family tree. I could create I think I could probably what tools came from what factory.
Do I have my slide on the screen now?
This one.
The slide with the chromosome number of the zebra and the donkey.
Yes,
and so on.
I have it up on screen. Go ahead.
Yeah. Okay. So these are the chromosome numbers of the different species within the horse family. As you see, they are widely different. And just looking at the animals, you would probably expect that the three species of zebra was more closely related to each other than to any of the other species. But as you can see, the chromosome number doesn't tell you anything about that kind of relation. And what we actually do, Mr. Hovind, now that you have so clearly demonstrated that you have no idea how phylogenetic analysis is actually done, then let me tell you. We use DNA sequences, Mr. Hovind. And the rest of you, here is phylogenetic. I have the reference in the bottom of the slide, based on mitochondrial DNA and some nucleotides, and the lines to the left show the relationship. The plains zebra, the imperial zebra are closer related to each other than to anything else. Next is the mountain zebra, and then the Kiang and the Kulang, they are donkey-like animals, are closely related and a little less closer related to the donkey, the domesticated donkey. And we have the domesticated horse and its wild close relative, Kultivatsky's horse. And this is the way it is done. DNA sequences, not chromosome numbers, not gene numbers, not anything else. DNA sequences. And the reason that it is a very, very reasonable way to do it is that what is actually inherited from one generation to the next is exactly DNA. So the variation that you see between the zebras and the donkeys and so on is based on the variation in DNA. So why not go to this to the corner of the question, that if you can look at how the DNA, how the DNA is related how the level of identity between the DNA from different species. If you look at that, then you have a very, very good measure of the actual phylogenetic history of this.
Okay, now, Stefan, let me ask you a question. Would you agree? Would you agree that back in Darwin's time, 1850s and 60s, the microscopes were not sufficient to see much more than a cell? Darwin thought a cell was just simply a little glob of jelly. They did not understand. Nobody knew what DNA was. When was this mitochondrial DNA discovered at all? And when did they start doing these sequences?
Until about 40 years or so, 30, 40 years or so, it was phylogenetics was done with a very, very detailed anatomical description. They looked as many details of the anatomy as they in any way could come over. But I'm pretty sure that until DNA was used for phylogenetic analysis, it was very, very difficult to come up with any good idea of how the zebra and the donkey and the horse was related, because they are so close.
Right.
They are so much identical.
I don't want to put words in your mouth. I want to try to explain to the audience what you just said. For most of human history, since Darwin's, anyways, for the first 100 years after Darwin, they arranged animals based upon anatomy.
Yeah.
And now they just started 40 years ago arranging them based upon mitochondrial DNA sequencing.
And other things. And the interesting story is that they came up with almost exactly the same history as they have built on anatomy. That's very interesting.
Well, that's your belief, I'm sure. That's why in my charts I pointed out, which were obviously a spoof about why didn't they use gestation period? Why would you use anatomical similarities to prove common ancestor? Why not use anatomical similarities and DNA similarities to prove common designer? Stefan, would you agree that these similarities in DNA, mitochondrial DNA, could prove the same designer wrote the code? Is that even an option in your thinking?
Yes, of course.
So it could be the creation, which says they're going to bring forth after their kind, is supported by the similarity of mitochondrial DNA, just like it is supported by the similarity of anatomy.
No,
they
it's
used
not.
for 100 years, and now they use DNA. I don't know what they're going to use next week, but all those things could just as easily be interpreted as evidence for creation.
No, it couldn't. Because if you, for instance, look at the horse family is part of the odd-toed ungulates. There are three families of odd-toed ungulates: the tapirs, the rhinos, and the horses. And if you look at the mitochondrial DNA from tapirs, rhinos, and horses, you will see that they match each other at a higher level than they match any other animal. Now, why on earth should the mitochondrial DNA, which has absolutely nothing to do with anatomy, it is very, very basic biochemistry, it takes care of. Why would mitochondrial DNA from a rhino look more like that from a tapir or a horse than any other animal? And coincidentally, that is exactly the odd-toed ungulate order, which has been recognized, I think, by Linnaeus 250 years ago. Isn't that odd? Isn't that just very, very strange from a creationist point of view, that the mitochondrial DNA looks exactly as it should if evolution was true?
It looks exactly as it should if creation is true also.
Why? Hey, stop there. Why? Why should you, as a creationist, expect the mitochondrial DNA from a horse to be closer, more identical to mitochondrial DNA from a rhino than it would be to the mitochondrial DNA from a cow? Why?
Yeah, our hour is up, but let me try to answer that question for you. The similarity, Microsoft Corporation, I don't know, Steve, how many different programs have they produced? Microsoft PowerPoint, Microsoft Word?
Start stepping the game.
Thousands and thousands, okay. Microsoft has produced thousands of programs. Some of them just games, right? Some of them high-tech military stuff, I'm sure, okay? How many of those have similar lines of code? How many have identical lines of code? Probably. Now, does the size of the computer that it fits in, can we determine anything from the anatomy of the computer, what's in it in the code? Or can you store that same code in a variety? Can I store it in a phone? Or can I store that same code in a computer the size of a house? Or a computer the size of a suitcase?
You're completely sidestepping the question.
No, I know I'm not. I'm trying to illustrate, Stefan, so you can see it. You're trying to say we arranged them by anatomy. Well, we could do that with computers. We could arrange the smaller cell phone, which is a computer, up to the giant, gray computer. We could develop a phylogenetic tree of computers, and we could also develop a phylogenetic tree of the amount of code it will hold. And we try to come up with imagination. See, all of that is imagination. You're assuming the animals changed at all. We never see it happening today. No horse produces anything but a horse. No bacteria produces anything but a bacteria. There are no examples of it happening. It only happens long ago and far away. This is your religion. I wish you could see that.
You don't even address my questions. You haven't. I waited half an hour for you to just come up with one simple word, DNA sequence. Mr. Hovind, let me finish this.
No, it's imagination.
I waited half an hour for you to come up with one single answer to my question.
I gave you the word.
Was DNA sequences, and you didn't come up with it because you don't know. And now I'm asking you, why would the mitochondrial DNA from a horse be more similar than the mitochondrial DNA from a rhino than it is from the mitochondrial DNA from a cow? And you don't answer the question. You start talking about something completely different. Why are there any pattern in the level of identity between these mitochondrial genomes? Why is it not just a complete mess? Why are there such a very, very fine-tuned pattern that fits exactly what you should expect from evolution?
The horse and the rhino have some of the same needs. They both need to walk on 4 feet. They both need to have a balance system. They both need to see. They both need to grow hair. So of course there are similarities in the DNA. They have lots of.
So does the cow. That's not an answer to why the mitochondrial DNA from a horse should be closer to the rhino than to the horse.
Well, if you want to believe that evidence you're presenting is evidence that we all have so you believe a horse and a rhino came from a bacteria. Would you agree that the DNA mitochondrial sequence of a bacteria is different than a horse?
You are sidestepping the question all the time. You are simply not addressing the questions that I ask you.
I'm pointing out the stupidity of it. I think my audience is
not. No, you are not. You are proving that you don't know what you are talking about because you have no answer.
I gave you an answer. The answer is
you didn't even address the question.
Stefan, the single word answer I would give is imagination. Imagine. You guys think a horse came from a bacteria, and you're looking desperately for evidence to support that. And when you looked at anatomy, oh, you found what you're looking for. And when you looked at DNA sequencing, oh, you found what you're looking for. But if you look at gestation period, or look at body weight, or look at lifespan, or look at number of offspring that's in my chart, well, that doesn't fit. So therefore, that's not what we're looking for. So we won't accept that. It's imagination. Hey, let's continue this another time. We've gone over an hour. I got folks waiting on me here. So let's go over this another time. You asked a question, do I understand how you do the sequencing? And my answer was imagination.
So DNA sequencing.
Pick another question. We'll do it next time.
Okay. Am I allowed to finish this?
Yeah. Go ahead and give a closing statement. I got folks waiting here. Go ahead.
Okay. I think that if you by now turn back an hour and listen to our conversation once more, you will find out that Kent Hovind didn't answer one single of my very, very simple questions, which he would have been able to do if he had paid just a little bit of interest into what evolutionary theory actually says. But Mr. Hovind has no interest in knowing what evolutionary theory or phylogenetic analysis actually is, because if he knew, he knows that he would have to lie to people in order to maintain his stupid stories about carrots going into chickens going into ferns or whatever. which has absolutely nothing to do with how evolutionary theory works or how phylogenetic analysis works. It was crystal clear. I waited about half an hour for an answer for how phylogenetic analysis was done, and there was no answer because Kent Hovind doesn't know. I asked the question several times, why is a zebra or a horse closer related to, or closer, genetically closer to a rhino than to a cow, and we got no answer. So I really hope that people will listen to this once more and see how you simply sidestep the questions all the time. Thank you.
Well, thank you, Stefan, for coming on. Let's do this again another time. I think I did answer your question. I think evolutionists for 150 years have wanted desperately for their theory to be true because they want to get rid of God. The Bible clearly says the animals will bring forth after their kind, and that's what the evidence has shown for all of human history. Every farmer on planet Earth will point out that it works. Whether it's corn, you plant corn, you get corn, you cross cows, you get cows. There are no exceptions. The word that describes evolution, the best of any word I know of in the world, is imagination. You imagine that horses and zebras and rhinos and cows and bacteria and fish and birds are related and all came from a bacteria. That is a religion in every sense of the word, in my humble, totally, completely unbiased and correct opinion. So thank you for joining us, folks. Stefan, let's call the secretary and schedule it again. I'm sorry, my schedule is just really hectic here. We got a lot going on, but come on over and visit Dinosaur Adventureland. We'll put you live on our program, and you can sit beside me. We'll have the camera on, and you can explain why you think horses and rhinos came from bacteria. I would love to hear about that. I'd like to see how you demonstrate the genetic mutations that are going to add enough information to change over, I'll give you trillions of years. We'll make it quadrillions of years to get a bacteria to turn to a horse. So keep up, keep studying. Eventually you can be an independent temperamental Baptist like me and give your heart to the Lord. That's what I'm trying, Stefan. I'm trying to win you over to the Lord. Thanks for joining us, folks. We got to go here. We'll see you next time. Stefan, let's do it again. Thank you.